Welcome to Buddha at the Gas Pump. My name is Rick Archer. Buddha at the Gas Pump is an ongoing series of conversations with spiritually awakening people and about spiritual topics of all kinds. We've done over 650 of these now. If this is new to you and you'd like to check out previous ones, you can do that several ways. Explore the YouTube channel. In fact, I encourage you to subscribe to it. We're reaching nearly 100,000 subscribers this year. And to subscribe, click the subscribe button, obviously, and then click the little bell that pops out after you hit the subscribe button. Or you can explore it on the website, which is actually better organized than the YouTube channel because we have a whole categorical index of all the interviews and several other ways that they're organized. This program is made possible through the support of appreciative listeners and viewers. So if you appreciate it and would like to help support it, there's a PayPal button on every page of the website. Also, you'll notice that we don't have a discussion feature enabled on YouTube. And that's because discussions were just very hard to moderate there. And, internet trolls tended to mess things up. So we have the discussion going on a Facebook group, and there's a link beneath this video to the specific discussion area for this particular interview. So if you click that and want to discuss the interview, you can do it there. Okay, my guest today is Bernard Carr. Bernard is Emeritus Professor of Mathematics and Astronomy at Queen Mary University of London. As an undergraduate, he read mathematics at Cambridge University, and for his PhD, he studied the first second of the universe, working under Stephen Hawking. He also became a good friend of Stephen's, shared an office with him, traveled with him, lived in his home. Perhaps he'll talk about that a bit as we go along. He was elected to a fellowship at Trinity College, Cambridge in 1975, and in 1980, spent a year traveling around the US as a Lindemann Fellow before taking up a senior research fellowship at the Institute of Astronomy in Cambridge. In 1984, he was awarded the Adams Prize, one of the UK's most prestigious mathematical awards. In 85, he moved to Queen Mary and became a professor there in 95. He also held visiting professorships at various institutes in America, Canada, and Japan. His professional area of research is cosmology and astrophysics and includes such topics as the early universe, black holes, dark matter, and the anthropic principle. He is the author of around 300 papers and the books Universe or Multiverse and Quantum Black Holes. He is also very interested in the role of consciousness, regarding this as a fundamental rather than incidental feature of the universe. And that's the main reason I was inspired to interview Bernard, and you'll see in a minute some of the things we're going to talk about. In particular, he is developing a new psychophysical paradigm linking matter and mind, which accommodates normal, paranormal, and mystical experiences. He also has a long-standing interest in the relationship between science and religion, especially Buddhism, having been the co-holder of a grant from the Templeton Foundation for a project entitled Fundamental Physics, Cosmology, and the Problem of Our Existence. He is president of the Scientific and Medical Network and a former president of the Society for Psychical Research. And I've spent an enjoyable week listening to many of Bernard's talks and other interviews and reading a number of things he sent me to read. And I accumulated several pages of notes. And last night it was like getting to be about 10 o'clock, and I realized my notes really weren't very well organized. So I had to go to bed. So I just sent them over to Bernard to show him what I had been accumulating. And like the story of the shoemaker and the elves, when I woke up this morning, I discovered that Bernard had organized them very nicely into 5 major topics. And I'm just going to read you those topics to give you heads up on what we're going to talk about. So the first is the multiverse and fine tunings. And obviously we'll define these as we go along. Time and consciousness, science, spirituality, and psychical research, quantum theory, and post-materialist science and hyperspatial models. So we'll try to apportion our time so as to do justice to all of those different topics, and the interview will last about 2 hours. So welcome, Bernard. It's wonderful to connect with you.
Thank you, Rick. And first of all, I must thank you for spending so much time reading my articles and watching my various interviews. And I hope it didn't deprive you of too much sleep last night.
Oh, I never deprive myself of sleep. And I listen to most of your interviews while hiking in the woods, which I do on a daily basis. So, killing two birds with one stone, so to speak. It was very enjoyable and very enlivening, and it definitely gets more of my brain cells firing. So it's not a chore. This doesn't feel like work by any means. So I think the first thing we want to talk about, unless you'd like to go back to your boyhood and how you got interested in all these things, we can do that now, or we can do that a little bit later. But we want to zero right in on fine tunings as quickly as possible. So you want to give us a little background, or should we dive right into fine tunings?
Let me just say, because I have really three main interests, and it might be interesting just to describe how they arose.
Okay.
When I was at school, I was at a public school called Harrow, and on one occasion I misbehaved, and as a punishment for my misbehaviour, I was roomed, which meant that I couldn't leave my room except for lessons. And so I had nothing to do except read, and I read three books. And those books, the first book was on the ABC of relativity, which was by Einstein. That got me interested in the nature of space and time and physics. Then I read a book called An Experiment with Time by J.W. Dunn, and that was about his precognitive dreams, and that got me interested in psychical research. And then I read a book called The Third Eye by Lobsang Rampo, who was allegedly a Tibetan Lama who'd taken over the body of a Cornish fisherman or something. And that got me interested in Buddhism. And really, those three books awakened my interest in science and in psychical research and in spirituality, which have really determined the course of my life in a way. And when I went up to Cambridge a few years later as an undergraduate, I immediately joined the Cambridge University Astronomical Society, the Society for Psychical Research, and the Buddhist Society, because I was particularly interested in Buddhism at that time. And so I've really pursued those interests all my life, and professionally, I became a cosmologist, so I became a scientist. And as you said, I did my PhD with Stephen Hawking. But I've always maintained my interests in the other topics, in particular in psychical research, and indeed in not only religion, but more generally in religious studies and the idea of spirituality. And so the three topics, which we'll all be covering today, really all go back to that period when I was about 15, and really all resulted by my misbehavior, which is rather ironic.
I wish my misbehaviors had resulted in such a productive outcome. Unfortunately, they didn't.
Well, I don't want to encourage any form of misbehavior, but it's
right.
It's funny how things turn out.
Yeah. It's interesting because Hawking was famously an atheist, and you were a close buddy of his. Did the two of you ever debate that topic, or did you just steer clear of it?
Oh, well, we talked about it because, I knew Stephen well. I lived with the family for a while. We had very different views. I mean, of course, in terms of psychical research, I took the phenomena seriously. Stephen had read the books by Rhine, I think, when he was a teenager.
J.B. Rhine, right.
J.B. Rhine. But he came to conclude there was really no evidence for it, so he didn't believe in that. As regards his atheism, of course, I disagree with that too. Stephen believed everything will be explained by physics. People sometimes say, well, why didn't I try and persuade Stephen to get more interested in spiritual matters? But I never saw that as important. Stephen was a brilliant physicist. He was a genius at physics. And I saw no reason to distract him by getting involved on the spiritual path. I mean, if he spent all his life sitting in meditation, which in a sense he might have been able to since he couldn't move his body, he might have become spiritually enlightened, but he would not have made such a great contribution to physics. And so I never felt any desire to actually convert him to my way of thinking. I mean, I think, the world needs great scientists and great spiritual people, but they don't have to be the same. And it seems to me that it's only a small fraction of people who are interested in both. So the fact that Stephen was an atheist never really bothered me at all, and I never really wanted to dissuade him. It's slightly ironic, though, that because Stephen was blessed by 4 popes and ended up being interred in Westminster Abbey next to Isaac Newton. So maybe if he does get to the pearly gates, they'll let him in anyway. But he was, of course, skeptical, but that didn't bother me at all.
Yeah. One point we might cover today is whether spiritual endeavors can actually enhance the study of physics, and vice versa, perhaps. That's an interesting area to explore. Okay, so that's a good introduction to how you ended up where you are. Let's plunge right in. I'm sorry, go ahead.
I can discuss how science and spirituality may support each other later on, I think.
Yeah, let's get into that. In fact, that's in our notes. So explain to us what fine tunings are.
Well, I'm happy to start off talking about this because in some sense this comes under the heading of my cosmological work, which, if you like, is more less controversial from a scientific perspective.
And I heard one interviewer describe you as perhaps the world's greatest expert on fine tunings. So
I wouldn't say that. However, what happened was that in 1979, I wrote a big review paper with Martin Rees for Nature, which was on the question of the so-called anthropic principle, which is to do with the fine tunings. And so that became quite a well-known paper because it was one of the first papers to get attention in a respectable science journal. But the idea is, it goes back to Brandon Carter, really, and people like Bob Dicke several years earlier. So I certainly wasn't the founder of the idea. Well, the idea is that there are certain coincidences in nature which seem to be necessary for our existence as observers in the universe. Most of what I'm going to say is in the context of the Big Bang model. But there are different sorts of fine-tuning, so it might be useful to distinguish between those. These fine-tunings are sometimes called the anthropic principle. Anthropic is the Greek word for man. It's a terrible word because these tunings aren't specific to human beings, but nevertheless, that's the word that Brandon Carter used, and we're sort of stuck with it now. What's called the weak anthropic principle merely says that given the constants of nature, there is a selection effect on when and where we must exist in the universe. For example, we have to be close to a star, for example. But a more interesting question is, why do we exist when the universe is as old as it is? The universe is actually 14 billion years old, 14 billion years since the Big Bang. And that means the size of the universe is roughly the distance light has traveled in that time, so 14 billion light years. So you might ask, well, why is the universe as big as it is compared to human beings who, of course, just exist on this very tiny planet? Well, you might just say it's just coincidence. The universe happens to be roughly 10 billion years old, and therefore it's 10 billion light years in size. But there's another argument which was given by a physicist called Bob Dicke in the 1960s, which says in order to have human beings, you have to have heavy elements, and those heavy elements are made in stars. But stars can only burn and then explode as supernova to produce the heavy elements after their lifetime, which is something like 10 billion years. So before roughly 10 billion years, there can't be any observers because there wouldn't be any chemicals. On the other hand, if you wait much longer than 10 billion years, all the stars will have burnt out, and therefore there wouldn't be any planets sustaining life either. So that was a simple argument which said that if observers are going to exist, it can only be when the universe is something like 10 billion years old.
So aside from observers, are you saying that there probably weren't any heavy elements until 10 billion years into the life of the universe?
That is the argument. Now, it isn't really 10 billion years. I'm being rather simplistic.
Roughly, maybe.
The first stars are bigger than that, and they would have produced heavy elements bigger than that. But I'm just using powers of 10.
Okay.
Now, notice this isn't saying the universe doesn't exist It's not apart from 10 billion years. It's just saying there aren't going to be any observers around at that time.
Right. But it's going to be all stars, which are basically just fusion reactions. And you might even say very few planets, because unless the heavy elements have been produced, we're not going to have planets.
Well, that's also true. I mean, that gets into the technicalities of how planets form. But the point is that this isn't controversial. This is simply saying the existence of observers actually imposes a selection effect on when you exist. And this is just a purely logical necessity. There's nothing controversial about that. So what's called the weak anthropic principle, I would say, is common sense. Where it becomes more controversial is when you ask, are the values of the constants themselves determined by life, whether life can arise? Now that's called the strong anthropic principle. Now, the evidence for that lies in a large number of strange coincidences involving the constants of physics. And I can't go through all of them in detail, but I'll just give you a sort of a taste of the sort of coincidences. First of all, you've got what are called the dimensionless coupling constants, which specify the strength of the four interactions. So you've got the gravitational interaction, you've got the electric interaction, the strong interaction, and the weak interaction. And they're all associated with coupling constants. That's to say, dimensionless numbers. And fundamental physics doesn't tell us what the values of those constants actually are. That we measure them, we know what they are, but we can't actually predict them on the basis of any theory. I mean, particle physics is very successful in understanding relationships between the forces. It can explain the unification of the forces, but it can't actually explain the actual values of the coupling constants. But what is remarkable is that there have to be certain coincidences between those coupling constants in order that, for example, stars and planets can exist. So, to give you a simple example, though it's very technical, you can only have both the stars, which explode as supernova, and the stars, the lower mass stars, which can have planets, if the gravitational fine structure constant, which is 10 to the minus 40, is the 20th power of the electric fine structure constant, which is roughly 10 to the minus 2. Okay, because 10 to the minus 2 times the 20th power is 10 to the minus 40. Now that's unexplained, and it explains why the gravitational force is so much weaker than the electric force. You can only have supernova exploding because the neutrinos which are generated in the core when the star collapses blow off the outer envelope, and that depends on nuclear reactions. And that only happens because the weak fine structure constant is actually the fourth power of the weak fine structure constant. The weak fine structure constant is 10 to the minus 10, so if you take the fourth power of that, it's 10 to the minus 40. But again, that's not explained. Now, I hope it's not getting too technical with the mathematics. I'll avoid mathematics from now on. But those are the fine coupling constants. There are also lots of relationships between the masses of the elementary particles, the neutron and the proton and the electron, between the strength of the strong interaction and the electric interaction, which are required in order to have interesting chemistry. If you didn't have fine tuning, you'd either have no elements at all, apart from hydrogen, or all your elements would be as heavy as iron, and that wouldn't work either. And finally, there are a lot of cosmological constants, which we can measure, and we know they're crucial to understanding the Big Bang Theory, but we don't know what those constants are. For example, there's what's called the photon to baryon ratio. That's the ratio of the number of photons in the background radiation, which is the evidence of the Big Bang, compared to the number of protons. And that's a ratio of something like 1 billion. And again, we don't know why it's 1 billion, but it just needs to be 1 billion for various reasons in order to have galaxies and stars and things like that. The point is that there are and the most famous one involves what's called the cosmological constant, which it's a bit too technical to go into now, but this is the dark energy which pervades the universe. And this was discovered only about 20 years ago, the universe is accelerating due to this. It's called a cosmological constant. That's what Einstein called it. It's due to the fact, the vacuum energy in some sense. And again, we don't really understand where this dark energy comes from. But again, it has to be finely tuned, because if it was too large, and naturally speaking, it should be much larger than observed. If it was too large, then it turns out it would stop galaxies forming because it's a repulsive effect. So that's an example of two cosmological parameters. There's also another parameter which determines the amplitude of the fluctuations that give rise to galaxies. So there are another set of fine-tunings involving the cosmological parameters. So just to summarize, because it's a bit technical, we've got fine-tunings associated with the fundamental interactions. We've got fine-tunings associated with the various particles in the universe, and we've got fine-tunings associated with cosmological parameters. And these tunings seem to be necessary in order for planets, stars, and people, or maybe just complexity in general, to arise in the universe. So that is the claim. It's a controversial claim because not everybody likes the idea that physics isn't going to explain everything. And it becomes, especially when you try to ask, well, what is the possible explanation for these fine-tunings? Now, that's another topic which I can talk about, but that's the sort of data, if you like, of that's what we mean by the fine-tunings. Some people say, oh, I don't believe in the fine-tunings, it's all a coincidence. And they like to say, well, no, the final theory of physics will predict one day all of these constants of nature. Maybe it will. Maybe the final theory will one day predict these constants of nature. But if so, it will remain a remarkable coincidence that the constants predicted are precisely what are required for life. And you know, it was originally hoped, for example, that string theory or M theory would explain all the different constants of nature. But that hasn't happened. And in fact, string theory specifically predicts that we have what's called the string landscape, which says this cosmological constant, which I mentioned, rather than having a unique value, could have a huge number of values, something like 10 to the power 500. So string theory itself is sometimes invoked as an explanation for the fact that you need the fine-tuning. But I now have to come on to the explanations, but I don't know if you want me to pause just to...
I do have a question. How many fine-tunings or constants are there altogether, approximately?
Well, I mean, the number of fundamental constants in physics, I mean, there are something like 30, 40 fundamental constants. So we know what they are. They're constants which arise in particle physics, and they're constants which arise in cosmology. But the real question is, how many of those constants are related? Because some of those constants are inevitably interrelated. So they're not independent constants. So the really important question is, how many of these constants are fundamental in the sense that they're independently determined? And that might only be something like a dozen or something. I mean, we don't know because we don't have the final theory. And the whole point about unification is that the more unified the model, the fewer the number of fundamental parameters. But there are at least the cosmological parameters, for example, as far as we know, they're what we call contingent. They're not predicted by a fundamental theory, and likewise in particle physics. So they may be of order sort of 12 constants, which are involved in these fine-tunings. The number of fine-tunings themselves, again, I could give you something like 20, but I mean, obviously they have different statistical significance. The question is really, how fine is the tuning? If constants are just given to an order of magnitude, it's not so interesting. What's interesting is when the fine-tunings have to be, they have to be obeyed to something like, a fraction of a percent. That's when it gets interesting. So let me just say that the number of fine-tunings and the degree of fine-tuning is sufficiently impressive that there's something weird going on, in my opinion.
Yeah. So let's say there's 12 or 20 variables. And if we can imagine them as being like a Las Vegas slot machine with 12 or 20 wheels, and each of those wheels has many of them have vast number of possible values, then we pull the handle on the slot machine, and somehow or other, all of these have lined up just right for us to have the kind of universe we have. And the statistical probability of that is probably mind-bogglingly small. And yet go ahead.
Yes, it's an appropriate analogy, the casino one, because the analogy I like to give is, let's imagine we're buying lottery tickets. Okay, so you buy a lottery ticket, and of course there are millions of people buying a lottery ticket. You win the lottery and you won $1 million, and you think, wow, that's a miracle. But actually, it isn't a miracle. It simply means that 1 million people have bought lottery tickets, and you happen to be the one who was lucky enough to find it. And that's precisely the analogy which most physicists at least like as an explanation for the fine-tunings. They say, well, maybe we've got lots of universes, a multiverse, and we necessarily have to be in one of the universes where the constants are right for life. So we're not saying the other universes don't exist, we're just saying that there's a selection effect on what sort of universe we can be in. And so in that sense, what's called the strong anthropic principle just becomes a reflection of what I earlier called the weak anthropic principle. Because you remember, the weak anthropic principle merely says the existence of observers imposes a selection effect on when and where you are in this particular universe. If you've got a multiverse, it's saying the existence of observers imposes a restriction on which universe you're in. And in that sense, the strong anthropic principle, which is controversial, becomes an aspect of the weak anthropic principle, which is not so controversial because it becomes a logical necessity. But then, of course, it depends on whether you believe in the multiverse, which is another question.
So it seems to me that the idea of the multiverse is kind of a cop-out for those who feel uncomfortable about the suggestion that all these fine-tunings turned out just right might be symptomatic of some organizing or underlying intelligence, that gives rise to the universe. They can say, okay, if there are a gazillion other universes, we just happen, and most of them are duds, we just happen to end up in the good one. So we're lucky. It was a matter of random chance. We don't need to resort to some kind of theological explanation.
Well, Rick, you put your finger on a very important point, because the reason, when I first wrote this paper with Martin Rees, it was very controversial. A lot of physicists hated the idea. One of my physicist friends even said it was obscene. Now, the reason it was seen as obscene was partly because it was seen as philosophy rather than physics. And that's fair enough, because it is on the borders of physics and philosophy. But
I'm just thinking of you could have a book called Pornography for Physicists, and it would just be all these formulae and explanations.
Well, yes, I've never heard it described as pornography, but again, it could be a good analogy, but I don't want to seem to be justifying pornography. However, the real reason I think it got such an adverse reaction was that it also smelt of theology. Because if you got the fine-tuning, the alternative explanation is obviously that there was a tuner, that in some sense a creator had tailor-made the universe for our convenience. In other words, you have the idea, if you like, that there was God, who you imagine a space of all the coupling constants, and God in some sense puts his pin in this space at the right value to produce human beings. Now, that's, of course, very different from the view in which you say there are millions of universes, or large numbers of universes, and we just happen to be in one of the small ones which produce life. So there has always been the controversy as to whether these anthropic tunings should be attributed to God, or whatever word you want to use, or to a multiverse. Now, obviously, theologians would prefer it to be God. Physicists would much prefer it to be in the multiverse, because in some sense, the multiverse does away with the need for a fine-tuner. Now, this is still a controversy. There are still some people who prefer to think that the fine-tunings reflect the existence of, if you like, a divine intelligence. But, of course, most physicists don't like that. Most physicists don't want to resort to God. Even if they believe in God, they want to keep him out of physics. And so there are a lot of atheist physicists who are converted to the idea of the anthropic principle precisely because of the multiverse. So you have people like Stephen Hawking, you have people like Steven Weinberg, people like Martin Rees, people like Leonard Susskind. All of these people are atheists who might at one stage have been very anti the anthropic principle, but now they're supporters of the anthropic principle. Well, most of them are dead, but they're supporters of the anthropic principle precisely because it is naturally explained by the multiverse. So in some sense, the fine-tunings almost become evidence for the multiverse. But I have to say that not all physicists think that. Some physicists think the multiverse is also rather too mystical. There are a lot of physicists who would like to think there was only one universe and there's no God. And so they think that the multiverse is just as mysterious and unpalatable as the idea of God. So I shouldn't give the impression that everybody, all physicists now accept the multiverse, but at least it is respectable. And when the word anthropic, 40 years ago when I first wrote about it with Martin, was really a taboo topic. Now it's become relatively respectable in the fact that very eminent physicists now will utter what used to be called the A word, anthropic. A lot of people wouldn't even use the word because it was almost pornographic, if you like. But now it's much more respectable. I mean, the field is, physicists are still split about it, but nevertheless there are a lot of eminent supporters. And it's really, I would say, all because of the multiverse. You can argue about whether the multiverse is actually proper physics. I mean, most of the critics don't so much disagree with the possibility of a multiverse. They just say it's not in the domain of science because you can't see the other observable. You can't see the other universes. There's no evidence for the other universes, and therefore this should be classified as philosophy rather than physics. I sort of have some sympathy with that view. But on the other hand, the frontiers of cosmology and particle physics have always been on the border of physics and philosophy, because there is always a period in the development of physics on either the macroscopic or the microscopic frontier where your theories go beyond the data, where you haven't actually got the data to confirm your ideas. And that, if you like, means you're in the domain of philosophy. And so it is true, at the moment we don't have any direct evidence for the multiverse, but nevertheless I don't see in principle why there shouldn't come one day evidence for the multiverse. In the meantime, we're in a sort of state of purgatory between philosophy and physics. I call it between cosmology. Cosmology is a branch of physics, but I refer to metacosmology, which is on the border between cosmology and philosophy. So I'm happy to regard the multiverse as part of the domain of metacosmology, as a compromise with those people who don't think it's proper physics. But the point is, I would like to stress, is that new ideas in cosmology have always been on the border, have always been in the domain of metacosmology. Originally, cosmology was just dismissed as a branch of physics until we got the evidence for the microwave background and Big Bang nucleosynthesis and the expansion of the universe. So yesterday's metacosmology is today's cosmology. Today's metacosmology, i.e. the multiverse, I think will be tomorrow's respectable cosmology.
Yeah, I heard you give a talk in which you traced the history of science in terms of its dismissal of things outside its purview as being metaphysical, and then science evolved to incorporate them and to find evidence for them, and therefore they were no longer metaphysical. But then there were other things outside that periphery, and it just continued to grow. So I think when a scientist makes a statement like that, they're really making a statement about the limitations of their discipline rather than about the limitations of the universe.
Absolutely. And the important thing to stress is that it's not just the universe is getting bigger as we expand our knowledge of it. The nature of science is changing, because the history of astronomy is you go from the geocentric to the heliocentric to the galactocentric to the cosmocentric, and maybe now even to the multiverse view. But at each, and that's on the macroscopic scale, and of course on the microscopic domain, we've also changed our view of the universe as we've discovered, atomic physics, which says objects aren't really solid, they're just mainly vacuum with particles. And then we go to quantum theory, which says that you don't have particles but waves. And then we go to even more exotic ideas, such as higher dimensions and things like that. So in either the macroscopic or the microscopic domain, our view of the universe is constantly changing. And not only the view of the universe, what we regard as legitimate science is always changing. So to give a simple example, I mean, Auguste Comte was a philosopher of the 18th century who said that there may be stars outside the solar system, but it will never be part of mainstream science, for the simple reason that we can never study these outside stars in the normal way of astronomy. And so he wasn't denying the existence of other stars, he was just saying they'll be outside the domain of science. However, just a few decades later, they discovered spectroscopy, which of course meant we could get information about other stars. And so immediately the domain of science expanded to the whole of the galaxy. And then there was a time when people said, well, the galaxy is science, but we'll never see beyond the galaxy. We don't even know if there's anything beyond the galaxy. You know, there was an argument just about whether the galaxy was the universe, because some people thought all those nebulae were inside the galaxy. And there was a big debate about that in the 1920s. But then Hubble came along in the end of the 1920s and showed that actually there were these galaxies outside our galaxy, the Milky Way, and indeed they extend for billions of light years. And now, of course, we're seeing them with incredible detail in the James Webb Telescope. So the point is that all these developments are expanding the domain of science. And although I'm talking about a problem in the domain of cosmology, I think this is an important message for the topics we're going to go on to talk about, that the domain of science itself is always changing with time. And science may resist that. Scientists themselves may resist that. You know, the cosmology has been controversial in the sense that at every stage it's developed, there have been more conservative scientists and even astronomers saying this isn't science. But so far they've always proved to be wrong.
I think it was Max Planck who said that science progresses through a series of funerals.
Yes. Well, the idea is, of course, that science, of course, goes through these paradigm shifts, as Kuhn famously wrote about. And these paradigm shifts arise when there are little anomalies which can't be explained. But inevitably, the mainstream people initially are going to defend the current paradigm. They're not keen to overthrow the paradigm because, after all, they spent most of their lives working in the current paradigm. And if you accept that's wrong, they might have wasted most of their lives. And so the idea has been that it's no good trying to convert some of these people. I'm not talking so much about the multiverse now. I'm talking about the topics we're going to go on to talk about later. More controversial topics like, consciousness and parapsychology and things like that. But even within the context of more traditional science, in the long run, you're not going to persuade a lot of the people. You just have to wait for them to die off. And that's why he made that remark that, science proceeds funeral at a time.
Yeah. Upton Sinclair said, you can't get a man to understand something if his salary depends upon his not understanding it.
Well, that is true. I mean, and but this is part of science. I mean, in my professional field of research, I'm very interested in the dark matter problem. And this is what we're going to discuss. But I have my own theory that the dark matter consists of primordial black holes which formed in the early universe. This is something I worked on with Stephen Hawking for my PhD. And this is, again, this was a minority view. Not many people took it seriously. Now it's becoming much more popular because of partly because we haven't found the particle physics dark matter, and partly because of the detection of gravitational waves which might conceivably have come from primordial black holes. We know black holes exist. There's lots of evidence for that, but we don't know that primordial black holes exist. These are the ones that form in the very early universe. And so it's a strange thing. I've spent 50 years working on these things. It's a minority view. If primordial black holes turn out to be the dark matter, then I've done something quite important. If they don't turn out to be the dark matter, then I've wasted a lot of my life. But the strange thing is, I, I probably won't know within my lifetime. And science is like that. You just don't know what's right or wrong. In a way, that's what makes it interesting. But the point is, if the dark matter is black holes, primordial black holes, then there are thousands of physicists who devoted their lives to showing its elementary particles, and they're going to be very upset, because that means they've wasted a lot of their lives, and indeed billions of dollars, trying to find these particles. So this is the strange thing about science. You never quite know the truth until you get there, and when you do get there, you're inevitably going to find that many people have been wasting their time. But it doesn't matter, because the joy of science isn't necessarily being true, because it takes a long time to discover the truth. The joy of science is actually working your way to the truth. And even if an idea turns out to be wrong, it very often turns out to be useful. You know.
Yeah. I mean, Columbus was actually a horrible man when you look at what he did, but he thought he was finding India when he sailed across the Atlantic, and he was wrong. But hey, look what we got.
Yeah, I mean, look at the great contribution he made. So I don't think you should judge scientists by whether their ideas are right or wrong.
Right. Yeah.
Because the point is, are the ideas useful? And and for example, primordial black holes, even if they don't exist, even if they didn't form in the early universe, they've been incredibly important, because these black holes are small, very small, much less than the mass of the sun. And this is why Stephen Hawking started studying their quantum effects. And Hawking came up with this remarkable result: the black holes aren't black at all. They radiate like black bodies with a temperature. And the temperature is inversely proportional to the mass. So it's tiny for something like the sun. But this was an incredibly important result, one of the most important results in 20th century physics, because it unified relativity theory, quantum theory, and thermodynamics. Now, ironically, we still don't have direct experimental evidence for this. This was discovered in 1974, so it's nearly 50 years old. We still don't have any evidence, but it's such a beautiful idea that almost everybody accepts it must be true.
So it works out mathematically, I guess.
It just is so beautiful mathematically.
Right.
John Wheeler, who coined the word black hole, he once told me it was such a beautiful theory that talking about it was like rolling candy on the tongue. Lovely idea.
Yeah.
But the point is that even if primordial black holes don't exist, thinking about them has led to this enormously important development in physics. So that's just a small example of how an idea can be useful even if it doesn't turn out. The idea of primordial black holes can be useful even if they don't actually exist.
Okay, I see some questions have come in, but we won't get to them quite yet.
Okay. I mean, obviously, we spent a long time on this, purely respectable in inverted commas discussion of physical ideas, but that's good. I don't want people to think I only work on more controversial, crazy ideas.
I've been playing with the thought that what if we could somehow verify the existence of the multiverse, and lo and behold, we discovered that all these other universes are fine-tuned for life also. I mean, what then? Would there have to be some kind of super multiverse that we would jump to in order to,
Well, that is interesting. I mean, of course, in a certain sense, if all the universes had the fine-tuning, you wouldn't have needed the universe in the multiverse in the first place. Alternatively, you could say the constants are fixed by the final laws of physics, but there are just lots of universes in which all the constants are going to have those fixed values.
Yeah.
The point is, cosmology is trying to explain the Big Bang. That's what quantum cosmology does. If it can explain one Big Bang, it can make other Big Bangs. Mm-hmm. If the fundamental theory of physics is going to uniquely determine the constants, you're simply going to have the constants being the same in all the universes. But you're asking a question, what your question really comes down to is this. Are the fraction of universes containing life really very, very small? Because you see, the assumption in the arguments I've given you is that you've got the millions of universes. We haven't said actually how many. You've got all these universes. They have different constants. But the idea is that only a very tiny probability that the constants are going to be right for life. So we're going to be only one of the tiny fraction of the universes which can produce life. However, that doesn't imply that there's only one. For example, one isn't saying that the constants may be uniquely determined. There might be different values of the constants which would allow life of a different form. For example, where we are carbon-based life, and maybe life could be based on something else. Or maybe there could be some form of life which doesn't even depend upon planets. So one isn't saying that, it's only one small set of constants that make life. There could be other sets of constants. But the idea, at least, is that it's only a small fraction of islands, if you like, in this multiverse where life can arise. So it's a tiny fraction. That's the idea. It's a tiny fraction of the multiverse which can allow life to arise. But I have to say, that's not the only view. There is another physicist called Lee Smolin, and he has a different view of the multiverse. I'll briefly describe. He says that you form black holes. The black holes form baby universes, and they create another universe. And then they form black holes, which create more universes. And he has the idea that every time you form a baby universe, you mutate the values of the constants. So this is a sort of analogy to evolution. And he argues that what happens is, therefore, the universe naturally evolves to one in which all the constants have values which optimize the production of black holes.
Huh.
So, but this, you see, of course, he's putting the emphasis on black holes rather than observers. But this has an interesting feature that most of the universes end up being having the constants required for black holes. So that's interesting. It's not the view I favour.
Yeah.
It's another view which says that in fact, most of the multiverses have got the right tunings, but for black holes rather than.
Interesting, but by the same token, they could also be fine-tuned for some form of life, and black holes are just the physical mechanism through which new universes are spawned. Perhaps.
Exactly. I mean, right. The point is, I think it's more natural to be fine-tuning the universe for the life rather than black holes. But the point about the black holes is that he has a particular mechanism for creating the multiverse. But then the point is that we have plenty of mechanisms for making multiverses anyway. They can come out of cosmology, out of what's called inflation. They can come out of string theory, out of what's called the string landscape theory. They can come because you come out of the many worlds interpretation of quantum mechanics. So there are lots of scenarios which would predict the multiverse. And in fact, although it's true that we don't have direct evidence for the multiverse, unless you regard the fine-tunings as evidence, the point is that there are theories which predict the multiverse, and that's the reason physicists take it seriously. There are theories coming from both cosmology and particle physics which seem to predict the existence of a multiverse. That's why physicists take it seriously. It may be disconcerting that we don't have direct evidence for the other universes, but that happens a lot in physics. I mean, there's no evidence, no one can see a quark, because you can't see a quark in isolation, but nobody doubts that quarks and the fundamental particles that make up protons and things, nobody can see inside a black hole by definition, but that doesn't mean we don't regard a black hole as part of physics.
Yeah, and the Webb has taken us back to perhaps 200 million years after the Big Bang, but that's a pretty great distance, and we can't see outside this universe to see other universes out there.
That's absolutely true. I mean, what is undoubtedly true within the concept of the Big Bang is that the universe doesn't end at the end of the edge of what's called the observable, what's called the horizon, which is how far light can have propagated since the Big Bang. There is no doubt that the universe, there is a bigger reality that goes beyond our observable universe. And indeed, there are different types of multiverses, but I won't get into that. It becomes a bit too technical. But just to go back to your original point about intelligence, is it evidence of intelligence? This has been a long-running debate. I once organized a workshop entitled God or Multiverse, because obviously theologians wanted to see the fine-tuning as evidence for God. The physicists want to see the multiverse as the explanation of those fine-tunings. But I've always said that it's not as simple as that. It's not a choice of God or the multiverse, because, as we'll hear later when we talk about other topics, I'm not against God at all, whatever the term means. And it seems to me that if you're going to believe in God or some great intelligence, I see no reason why that great intelligence can't create a multiverse as well as create a universe.
Yeah.
I think the problem is, if there's only one universe, maybe you do have to invoke some special tuner. But if there's a multiverse, it doesn't exclude the possibility of a tuner. It merely says you don't necessarily need one.
Well, the Hindus have this image of Vishnu lying on a couch and just sort of almost like blowing bubbles, churning out multiple universes. So they have the idea.
Exactly. In fact, that's a nice image. In fact, I should use that in one of my articles. It's a beautiful image, blowing bubbles.
Right.
The different multiverses, yeah. And in fact, in some of the inflationary scenarios, that's what you have. Your universe corresponds to different bubbles.
Yeah.
In all of which you have different values of the constants. But it's just the standard picture doesn't include Vishnu.
We'll have to work that in. You may have heard the quote from cosmologist Brian Swim, whom I'm going to interview in September. He says, you leave hydrogen alone for 14 billion years and you end up with giraffes, rose bushes, and opera, something like that. I have a question to tag on to that. However the constants in our universe or any universe may be configured, why should there be any constants or anything at all? Why wouldn't any constants or laws of nature be expressions of some form of orderliness, or one might argue intelligence? So if the constants in other universes don't give rise to life as we know it, doesn't the emergence of any degree of complexity suggest some form of organizing intelligence?
Well, you raise a lot of issues there. First of all, I'm glad you used the word complexity, because I don't like the word anthropic when we talk about the anthropic principle. I tend to think of it in terms of the complexity principle, because these fine-tunings aren't specific to human beings. I mean, they would be required even for making television sets or something like that. But the key thing is the Big Bang, the history of the Big Bang has manifestly created complexity. It's created a hierarchy of complexity. And that's indisputable. We can see what happens. We start off with the void or whatever, and then we create elementary particles, hadrons, and then as the time goes on, the hadrons, you've got the atoms, the hydrogen undergoes nuclear interactions and produces the light elements like deuterium and helium. Then you produce the stars, and the stars then produce the planets and heavy elements, and then you get molecules and biomolecules, and then you end up with human beings and brains and things like that. So this embodies the quote you gave before. There's no doubt that there is this hierarchical build-up of complexity. But what isn't always appreciated is that build-up of complexity only arises because you have fine-tunings. Unless you have the fine-tunings, which I've talked about, you won't end up with that. I call it a pyramid of complexity, with, if you like, minds at the top. Without the fine-tunings, you won't go through the various critical stages, which end up at the top of the pyramid. So, for example, you won't have any chemistry elements unless you have the fine-tunings between the strong and the electric coupling constants, for example. But so, to me, the crucial issue is complexity. But then you've got to ask the question, well, how does complexity arise? Now, a lot of people say, well, doesn't this go against the second law of thermodynamics? Because the second law of thermodynamics sort of says the universe should be, the entropy should increase. In other words, the order decreases. And so for a long time, if you go back to the 19th century, people used to say, well, you'll have a heat death. The universe inevitably will run down and any form of life will disappear. However, we know that's not the case, because what actually happens is that we know there are nonlinear processes which inevitably generate complex structures. This is so-called chaos theory. But this doesn't go against the second law of thermodynamics, because although you're locally producing order, increasing degrees of order, the entropy is increasing in the outside, in the rest of the universe. Okay, so the total entropy of the universe is increasing, but it's just that in a small fraction of the universe, the order is increasing. And that's why it's a pyramid, because as you go up towards the top, the fraction of the universe in this assembled order is going down, but the total entropy of the universe is still increasing. So the idea is you get pockets of low entropy or pockets of order which are forming in a universe where the total entropy is increasing. So there isn't a direct conflict with the second law of thermodynamics, and it means the original view of a heat death, which people used to talk about a long time ago, fortunately that turns out not to be correct. There's no reason why the order can't continue to grow, at least if the universe has got these fine tunings. But actually, you started off with an even deeper question, I think. And you were asking the question, I think, quite apart from the fine tunings, why is there anything here at all? Am I interpreting?
Yeah, like I've had this discussion with this guy for some time, and he says, well, we don't know how the laws of nature came to be, but if you grant us the laws of nature, we can explain how the universe evolved. But I won't grant him the laws of nature, because why should those arise? If everything is just random billiard balls, why should there be these local pockets of order? What is the force which forms those? And to me, I keep resorting back to the idea of a field of intelligence rising in impulses of intelligence, and giving rise to order against all, forces to the contrary.
Well, yes, but I think you have to be careful here, because really it comes down to the question of what came first, matter or mind. Ultimately, you're asking, how did the universe arise? I mean, I don't like to address the universe. I don't like to address the question, why is the universe here? Because that is a clearly philosophical question which I'm not qualified to answer. But I think you can ask the question, you're really asking the question, is there an intelligence that underlies the universe?
And by mind, the word mind often has an individual connotation, but we're talking about some kind of cosmic mind or
Absolutely.
Oceanic field of pure intelligence.
When you study, physics as being triumphant and coming to understand the laws of physics, the way everything is connected, you've got the links between the macro domain and the micro domain. We know there's interactions between all the forces of nature. We even think we're close to a final theory of physics. Now, I think that's a rather pretentious claim. But what is remarkable is that these laws, that the universe is all put together in this coherent, beautiful way. I mean, it's all. I think it was Jean who said it's almost like it's a great thought. That the universe, in some sense, smells of some great intelligence, simply because the laws of physics are so clever, if you like. And so, no, I'm deliberately not invoking God, but I'm just saying you do get the impression that there's a great intelligence behind it.
Yeah, you can invoke God, but we just have to define the term, because most people's conception of it is so, anthropomorphic. Or
that's why I don't like to use the word God, because it's so provocative, at least to my cosmology friends. But the point is, I think there are many reasons for thinking that mind is a fundamental feature of the universe and not an incidental feature. I mean, the normal view is, that you've got this build-up of complexity, which is all going on at the level of matter. But then when you get to a certain degree of complexity, you produce brains, and then brains produce consciousness and minds. So one sees mind as simply the sort of the end product. It's a culmination of complexity, if you like. And that's clearly true, that minds, what I call a little m, are a result of that process. However, I think you have to distinguish between mind with a little m, which is our individual minds, and what I would call mind with a big M, which is some collective mind. Now, we'll probably get onto this later. But so for me, there's a big distinction between mind with a big M and the mind with a little m, which is the billions of us. Now, clearly, minds with a little m did not exist until whatever it was, 10 billion years after the Big Bang. We know that because we understand how minds with a little m did evolve through the brain. But that doesn't mean there couldn't be some form of mind with a big M that pre-existed the Big Bang, because physicists still don't answer the question, what happened before the Big Bang? So I don't reject...
Yeah, and let me just throw in here, there could be minds with a little m, but bigger minds, because they are the minds of beings who don't need meat puppet suits, carbon units, that, celestial beings, things like that, who would still exist now. And you get into this in some of your talks when you use the phrase, what was it, specious present, beings which might have lifetimes of millions of years and so on, but who exist in subtler realms and who could actually be instrumental in some way in the formation of the universe, like the agents, as it were, of cosmic mind. Anyway.
Well, yes. I mean, I'm not sure if I should get into that part of the discussion now, because it sort of goes off on a tangent. But you're quite right to raise this point, because when I make a distinction between mind with a little m and mind with a big M, that's rather simplistic, because I'm actually arguing that there is a hierarchy of consciousness,
right,
which corresponds to a hierarchy of minds. And so when I'm talking about mind with a big M, I'm really talking about the final step of the hierarchy. Really, there are a series of minds with ever increasing, decreasing size of the M, if you like.
Yeah, we could think of it as like the ocean versus various waves of various size, little ripples, big waves, and so on. But they're all just expressions of one vast ocean.
Yes. But I think maybe I should get into that as a separate topic later. But the point I'm making is that I see no reason in principle why mind with a big M should not have pre-existed the Big Bang, and therefore I see no reason, because not only that, in my own perspective, I think there are levels of reality that go beyond ordinary physical reality anyway. Again, now I'm going against the mainstream view of physics, but I think there is an extended reality which would not be described by normal physics at all, and which, if you like, is a mind-like reality. And that mind-like reality, I don't see why the universe itself shouldn't have come out of that. Indeed, the physical universe shouldn't have emerged from that. And of course, that is the view which you get in the standard esoteric doctrines. That you started off with mind, and in some sense, it cascaded down to the level of physical creation. So all I'm saying is one has to be very careful, because if mind, what you asked about intelligence, you see, if mind with a capital M preceded the universe, in principle, I suppose you could say intelligence with a capital I might have preceded the universe. But then, of course, you're getting very close to invoking God. And this is where I get into big trouble, of course, with all my scientist friends. So I make a distinction between, I'm not an advocate of intelligent design. Of course, intelligent design, as the fundamental as Christians we use the word, is really saying there is one universe and there's one God who's very intelligent and created the universe with his great intelligence for our benefit. I'm not saying that. All I'm saying is that, because I'm not saying there's only one universe, I'm just saying that because you've got a multiverse, you don't necessarily need to invoke God. I said that before. There's no need to invoke God. On the other hand, that doesn't mean there isn't some form of mind. And my personal view is that there is a form of mind. And therefore, you could say there is a form of intelligence. Because whatever this... I mean, you can ask the question, how intelligent is God? I don't think anyone could ever measure his IQ. But, I mean, there is a question about whether it's even meaningful to ask if there is such a thing as a God, what is God's intelligence quota? So you have to be very, very careful. And so in these conversations, I try and be as conventional as possible. I make a distinction between intelligent design and the possibility that there is some level of mind and some level of intelligence which preceded the universe. Because if you do that, the intelligent design somehow suggests that everything was done for our benefit. Okay, that it implies that humans are unique and the whole universe is here for our benefit. This is certainly not my view, because in my view, even if mind is fundamental, mankind is not particularly special. You know, I mean, there could be civilized consciousness all over the galaxy. There could be consciousness at all sorts of different levels. And it's really just a question of how much emphasis you put on mankind, humanity, I should say, rather than mankind. How unique is humanity? So but there is a subtle distinction between this view and normal intelligent design.
Yeah, I would say the way things are going here, if humanity is unique and special, then God isn't a very good designer.
Well, that's true. I mean, yes, we were apparently created with the ability of having free will, but it doesn't seem to be going so well but that's why I don't think we should put too much emphasis on humanity. You know, we just happen to be top dog at the moment, but, you know, we could get wiped out by an asteroid. We know from the history of evolution that, you know, there have been these catastrophes 60 million years ago, the dinosaurs were wiped out. We face far more immediate dangers here on Earth, which could wipe out humanity. I mean, be it asteroids or viruses or nuclear war or environmental catastrophes. So I'm just not putting too much emphasis on humanity. But even that's controversial, because most people now take the view that probably, you know, we know the galaxy is teeming with planets, okay, and so there could be, and those planets, many are going to be like Earth, so I see no reason why there shouldn't be extraterrestrial intelligence within our galaxy. We don't know because we haven't detected it yet. So I take the view that there could be many forms of intelligence, and therefore we're not so special. But there is another view which actually says that we are unique after all. That would be a bit of a detour. Brandon Carter himself, who coined the word anthropic principle, he had an argument that life is very, very rare and that we're probably unique in the galaxy. So there is another view. Either way, it's very important. Either way, unique, in which case, you know, we have to preserve ourselves. It's really important. Or there are thousands of civilizations, and that's exciting too, because it means that eventually we will become part of some greater galactic level of consciousness, if you like.
Yeah, even if we're unique in the galaxy, which I doubt, there are at least a couple of trillion galaxies. So,
well, exactly.
Right. You know, there's a song that's one of the lines is "God is watching us from a distance." I won't try to sing it. And my conception of God is not like that. You know, I mean, somewhere in various scriptures, it says, you know, it describes God as omnipresent. And, you know, if you look at Vedanta, they would say, and many other traditions would say, that it's all God, you know, and within the omnipresence of God, there are all sorts of self-interacting dynamics taking place, which give rise to the appearance of various types of manifestation. And I don't know, the reason I find that inspiring is that whenever I look at anything, a blade of grass or one of those animated, you know, displays of the mechanics of a cell or something, it's just, I just feel like God is hiding in plain sight. By God, I mean this omnipresent intelligence. And you know, the thought that any of this is happening randomly or accidentally or just seems so alien to me. What do you think?
Well, yeah, and but I think that raises an important point, because you know, I'm not a theologian, so any theological remarks I make may be naive, but I can only express my view, and that is that I talk about our little minds being part of the bigger mind, or our little consciousness being part of a bigger consciousness. But the idea of this is that the bigger mind is here and now. It's not just at the beginning of the universe. We are part of the bigger mind here and now. So, I mean, whatever one's view, I don't like using the word God because it means so many different things, but whatever one's view of God or this greater consciousness.
We can call it cosmic intelligence or whatever
cosmic
we want.
Consciousness, whatever
it is. Brahman, whatever.
Exactly. I feel it has to be evolving. So it's the big consciousness which is evolving along with all the little consciousnesses. The little consciousnesses are born and die off, and they contribute some illumination. But it's the big consciousness which is evolving. And so to me, this pyramid of complexity, it represents the evolution, if you like, of divine consciousness itself. That is my perspective. And in fact, so one shouldn't think of, from this view, you don't just think of cosmic consciousness as there in the background. You know, it kicked things off and stood outside as the universe carried on, and human beings arose and carried on doing all their own things and destroying themselves. You have to think of this cosmic consciousness as being there all along, because from a philosophical perspective, I like the idea. You know, you can ask the question, well, why did God create the universe? Why has consciousness with a big C fragmented into billions of consciousness with a little c? The only answer I can give is the answer which is given in many religious traditions, is that God was, in some sense, he was trying to understand himself. He was creating all these billions of beings to view the universe, because this is how he was understanding himself, coming to know himself and coming to evolve himself. So from my perspective, it's not only, it's God's consciousness itself in some sense which is evolving. Now, that may sound heretical from some religious perspectives, because God is perfect, but it's not a unique view. Of course, quite a, you know, Teilhard de Chardin has similar views that in some sense consciousness is evolving, and conscious with a big C is evolving as well.
Yeah, Saint Teresa of Avila actually said, it appears that God himself is on the journey.
Well, she's put it, I didn't hear that. I hadn't heard that phrase, but that's exactly right. God himself is on the journey. In fact,
right.
I will use that phrase in some future writing, because it's a lovely...
I'll look it up and make sure that it's exactly as I stated it, because I might have paraphrased, but that's basically what you said, yeah.
Because I think that's so important, because we mentioned earlier how in science, it doesn't matter whether you're right, it's the journey which is important, not the destination, because we may never reach the destination, we may never have a final physics. And what you're saying, or what St. Teresa is saying, is that, well, actually, God is on the journey too, which is a nice idea. Of course, we've now gone way beyond my professional cosmological expertise.
Okay, a bunch of questions came in. I want to try to get some of them in with,
okay,
and at the same time, and have us continue on in the points that we're planning to talk about here. But let me just throw them out. And, you know, you don't have to give long answers to them, or you might even say, I don't want to answer that one. So let's just see here. So Elizabeth Mila now in Colorado asks, what is the implication of Gödel's incompleteness theorem on the search by physicists for a theory of everything? And would it be fair to say that the incompleteness theorem allows us to posit realms of spiritual truth that the conceptual mind will never and can never have access to?
Well, I mean, this is something which there's been much debate about. I mean, Gödel's theorem is a statement within the context of mathematics. You know, that there are certain statements that can neither be true or untrue. And that was a remarkable revelation by Gödel, but undoubtedly true. So then the question is, does Gödel's theorem transfer to physics? Are there things in your physical model which will never be known to be true or untrue? And again, one's got to bear in mind that physics basically is described in terms of mathematics. I mean, all the equations of physics do relate to mathematics. Mathematics is the language of physics. And indeed, in some sense, that's one reason for thinking that the universe is mind-like, you know, because mass is in the domain of mind, and it's one of the great miracles. You know, why is mathematics so extraordinarily effective? So then you might think, well, Gödel's incompleteness theorem in mathematics should imply that there's an incompleteness theory in physics. I don't think I've heard it argued either way. It depends what your final theory of physics is like and what's the final mathematical theory. I don't think it necessarily implies that a final theory of physics is incomplete. But the question that I think, was it Elizabeth is raising is really the deeper question, independent of Gödel's theorem, is can you hope for physics to give a complete description of all experience? And of course, that is far from certain. I mean, physicists claim rather arrogantly they're close to a theory of everything. I've never believed that, because it's only a theory of physics. And the theory of everything is a theory of fundamental particles and things and their interactions. the theory of physics makes no reference to consciousness or my own internal world. So I want an expansion of physics which accommodates the mind as well as matter. And so it's clear that the theory of everything, so-called, will not do that. Now, there may be a bigger theory of everything, and an extension of physics will do it, will do that, and I like to work towards that. However, I would never claim that whatever that final theory is, that it's going to explain everything in experience. I'd never explain that all mystical experiences can be reduced to equations or anything like that. So personally, I fully accept that there is a limit to what can be explained in terms of physics.
Yeah.
I just feel, because I'm a physicist and I've seen how successful physics is, I just feel that one should push the frontiers as far as possible. And I feel they can be pushed much further than they have been so far. I feel you can push the frontiers into the domain of mind and spirit. But I'm not arguing that everything will then be reduced to physics and mathematics. But that's sort of independent of Gödel's theorem. I mean, you might be able to use Gödel's theorem as a subtle argument for why physics is incomplete. But I don't think you need to use Gödel's theorem to come to that conclusion. You can simply say mystical experiences are inevitable and go beyond rationality.
I like to think that a time will come when the science of consciousness, if we want to call it that, and physics and other sciences will merge in a way, and the best of both worlds will form a single science, which will, properly integrate consciousness with the methods of physics. And I think maybe then we'll be able to have something like a theory of everything.
Rick, that is my own dream, and maybe we can come on to that in more detail. It's one of our 5 topics, although I'm not sure.
Well, we can go a little long if you want.
Yeah.
And
so anyway, thank you to Elizabeth for that question, which I hope I partly answered.
Good. And remember, since we're pinched for time, you don't have to give long answers to these questions. Just answer them as much as you want, or you don't even have to answer them if you don't think some of these are relevant. This one is from Tristan Hanlon in Manchester, UK. What is the significance of the cosmological axis of evil? Does that mean anything to you?
Well, this is a more technical question. It's to do with, you see, the standard cosmological model. I mean, it says that the universe began with a Big Bang, but it also says the universe should be what's called isotropic. It should look the same in all directions. I mean, obviously, this is only on a large scale. Obviously, there's all sorts of structure on the scale of galaxies and clusters of galaxies. This is what the James Webb Telescope is looking at. But the assumption of mainstream cosmology is that on a large enough scale, the universe looks exactly the same everywhere. And in particular, when you look at what's called the cosmic microwave background, you're looking back to a very hot early stage of the Big Bang. And this has the same temperature, roughly 2.7 degrees everywhere, apart from small fluctuations. And these small fluctuations are which eventually give rise to density fluctuations, which generate galaxies and planets and eventually people. So that's the standard picture. And it's all based on what is said to be the standard Friedman-Robertson-Walker's model, which is a solution which has this property of homogeneity and isotropy. Maybe that's too technical. It's basically saying the universe looks the same everywhere if you look on a large enough scale. And that underlies all our Big Bang cosmology. But all along, people have been worried about little anomalies which arise, which suggest that the standard picture, while very successful, may not be completely successful. For example, those little fluctuations in temperature in the microwave background, they fit in beautifully with what is predicted by the inflationary scenario. The inflationary scenario says that the early universe went through an accelerated expansion phase, which generated the fluctuations. And one of the triumphs of this picture is that it was confirmed by the temperature fluctuations of the microwave background. However, there are other anomalies associated with observations of the microwave background which don't fit in so nicely with the standard picture. And this axis of evil is saying that instead of the universe looking the same in every direction, there seems to be a preferential direction, a sort of asymmetry, or there's what's sometimes called the cold spot. You know, in other words, the universe doesn't seem to be exactly the same on all scales. in other words, that seems to be suggesting that the standard picture does not work completely. Now, this would get into too technical of a discussion. Let me just say that I think there's no doubt that in some qualitative sense, that the Big Bang picture seems to be correct in the sense that the universe started off in a more condensed state and probably went through this early inflationary phase. But we certainly don't understand everything about it. We certainly don't understand what happened when you go right back to the initial singularity, t equals naught, if you like. We don't know what happened there. The universe may have bounced. There were all sorts of quantum gravity effects. And of course, if we believe we're part of a multiverse, there could be other universes or other bubbles which we interact and cause anomalies. So the point is, from this perspective, the multiverse, I'm not saying the multiverse explains the axis of evil, but I'm saying we don't understand everything about standard cosmology. And that could even be, and some of the things we don't understand might even indicate that there are other universes as well. So, but you occasionally read in the press, the Big Bang Theory is dead and it's facing a crisis. And of course, there are little problems which are arising. We still don't know what the dark matter is, and we don't know what the dark energy is. There's a huge amount we don't understand. So no one would say the Big Bang Theory is the final theory, but at least I think the basic idea that we started with a hot condensed stage, I think that's incontrovertible.
Okay. My old friend Bill Cote from Maui sent in a question. He said, what are some of the proofs required to verify the existence of the multiverse?
Well, I mean, the point is this, that what do you mean by proof? Since you can't see the other universes in the standard picture, you can't directly prove them. All you can hope to do is to prove the theories that predict them. Now, for example, the multiverse may be predicted by M theory. This is the idea that you've got all these extra dimensions, and this is what predicts the so-called, the string landscape scenario. And so you might say, well, okay, M theory is perfectly respectable in the sense that some of the biggest brains in the planet work on it, and it's respectable physics in the sense that bright physicists work on it. But one has to say that there is no direct evidence for string theory either. It was originally hoped that string or M theory would explain all the constants, but after 30 years it hasn't done so. And so some people therefore say, well, therefore this isn't physics, it's just mathematics. And so therefore we can't count that as proof. And it's true, we don't have yet proof that M theory is correct, and therefore we can't say that M theory has revised proof of the multiverse, because we haven't yet proved M theory. But it's just a question of time. The idea that you're going to solve all these equations in 20 years is just wishful thinking. It may take 100 years before we can find the solutions of M theory, if M theory is correct. We just have to be patient. This is what I earlier called metacosmology. There's a time gap between having a theory and verifying it. And bear in mind that everything in physics takes time. I mean, gravitational waves were predicted in 1916, but weren't detected till 100 years later. Black holes were predicted at roughly the same time, but weren't discovered for 50 years. The Higgs particle was predicted in 60s and wasn't discovered for 50 years. So you just have to wait a long time for the proof, if you like, to arise. Now, so I would say at the moment, you don't have proof. You've only got indirect evidence. I said I regard fine-tuning as indirect evidence, but it's indirect, it's not proof. Now, that's not to say that there could never be proof. Some people think you could have scars in the microwave background that could relate to collisions with other universes. This relates to the previous question, about the axis of evil. Who's to say? We know in relativity theory you can have wormholes, where you can go to distances which you shouldn't be able to go to, because the light travel time is too long. But who's to say one day we won't go through a wormhole into one of these other universes? So I think people who say we can never provide proof of these other universes are too pessimistic. May turn out to be true, which would be a shame, but it's far too early to say that. I think that I think eventually there may be proof, but there isn't proof at the moment. At the moment, it's just speculation.
Okay, good. Here's a question from Robert Bonomo in Tunis. I guess that's Italy, or is it? What do you think of the idea of space-time having been proven to be not fundamental? Donald Hoffman argues this, saying that while they work well as qualities of existence, they are not truly there. Any thoughts?
Yes, indeed. But this really goes on to the later topic. But let me just say that the idea of space and time are purely classical concepts. And of course, in relativity theory, space and time emerge as part of space-time, a four-dimensional continuum. But the whole point is, we know that general relativity itself must break down at sufficiently high densities. So the idea of space and time must break down at the Big Bang itself. And this was the significance of the work of Stephen Hawking and Roger Penrose, who showed that there must be a singularity, not only in a black hole, but at the beginning of the universe. It's a point where general relativity breaks down, where space and time no longer exist. So whatever our final theory of physics is, it's got to be the theory which is going to marry up relativity theory and quantum theory. Whatever that final theory of quantum gravity is, space and time will no longer have the standard behavior. And space and time may not even exist. And physicists argue about whether space will turn out to be fundamental and time is emergent, or whether time is fundamental and space is emergent, or whether space and time are both emergent. So we don't know the answer because we don't yet have a final theory of quantum gravity. But what is clear is that space and time are not going to maintain their standard form in our final theory of physics. Now, how that relates to Donald Hoffman's ideas is more subtle, because he's talking about the nature of perception and the nature of mind. And I think that's another reason to say you have to go beyond space and time, because when you're talking about experience, mental experience, you have to go beyond normal physical space and time as well. But I think I'll postpone that to the later topic.
Okay. Might have a break for lunch before we get to these later topics. No, we'll get to them. There's a question from Cedric Orange in Sacramento, California. What's the possibility of the James Webb Space Telescope revealing new, quote, God particle information or more updated Big Bang Theory information? Do you think those new discoveries might be related to spirituality from a metaphysical perspective?
Well, when you're talking about the God particle, you're really talking about discoveries made with accelerators like the Large Hadron Collider. I mean, the Large Hadron Collider is what detected the God particle. As opposed to telescopes. I mean, telescopes are looking out to the largest distances in the macro domain. Accelerators are looking to the smallest distances in the micro domain. Because, you know, to go to smaller scales, you have to have more and more energy. So the God particle itself is not being discovered by the James Webb Telescope. That's being discovered by accelerators. But what is interesting about cosmology is that the very large meets the very small at the Big Bang. This is because when you look, you look at great distance, you're looking into the past. You look a million light years away, you're looking a million years in the past. So when you look to 10 billion light years, or more precisely 14 billion light years, you're actually looking back 14 billion years in the past when the universe was very small. So in some funny way, the very large merges with the very small. So there is a link between particle physics, if you like, which is probed by Large Hadron Collider, and cosmology, which is probed by telescopes. Now, that said, the James Webb Telescope is going to provide all sorts of indirect evidence. It's going to tell us about the history of the universe, the history of galaxy formation. That's going to throw light on the nature of the dark matter and the nature of the dark energy. And we don't know what the dark matter is. We don't know what the dark energy is. The dark matter might be some elementary particle, which we're looking for at the Large Hadron Collider and other accelerators, or it might be a primordial black hole, which I like, in which case we're more likely to discover it through astronomical observations. But whatever, the point is, you never know in advance what these new telescopes are going to discover. It's always the unexpected which is exciting. But we can be confident that the James Webb Telescope, besides providing these beautiful detailed pictures, is going to give us fresh insights into the history of the universe, how galaxies formed, how the big black holes in the center of them formed, and everything is linked together in cosmology. All these problems the nature of the dark matter, the nature of the dark energy, the existence of the black holes, the big black holes in galactic nuclei. Everything is linked together. And it's like a detective story where the clues come from all directions. So it's a combination of something like the James Webb Telescope and something like the Large Hadron Collider. It's the two together which are going to provide the answers. So that's what's so exciting.
Interesting. Well, I hope the Webb telescope lasts a long time. One of its mirrors got dinged by a rock the other day.
Oh, I heard that. Yeah,
I know. Oh God, it would be so tragic if it.
I was away when this was announced, so I didn't read the paper. But the point is, it's a million miles away, and if anything goes wrong, we can't
be fixed. No.
Unlike the Hubble telescope, where we just sent the space shuttle up to repair it.
Right.
We can't repair this, so let's hope there's not too much damage.
Yeah. Okay. This question your answer might be technical, and we want to save time for other things, but I'll ask it quickly, and you can tell me whether you want to answer it or not. Ian Mannings from the US is asking, what is the expected range of masses for primordial black holes, and how might they have formed?
Well, this is my field of speciality, so I'm delighted to answer this question, though I could talk about it for hours, so I resist the temptation. Essentially, a black hole can form at any time in the early universe, and its mass is essentially what's called the mass within the horizon when it forms. That's to say, the distance light can travel. And its mass can be anything as follows. If it forms at the very beginning of the universe, what's called the Planck time, it would have the Planck mass, which is 10 to the minus 5 grams. Okay, that's a macroscopic object. It's like, a mass of a grain of sand, but it's small. On the other hand, if it forms at 1 second, it would have a mass of about 100,000 solar masses, which is very large. And so really, primordial black holes in principle could have the whole range from microscopic black holes 10 to the minus 5 grams all the way up to, say, 1 million solar masses, the sort of black holes which exist in galactic nuclei, for example. And in particular, there's a very special mass. It's a mass of 10 to the 15 grams, which is about the mass of the mountain, but the size is about a Fermi, the size of a proton. And this is the mass of the black hole, which is evaporating today due to Hawking radiation. Because Hawking says that the black hole has a temperature inversely proportional to its mass. That means that it evaporates on a time scale proportional to the cube of the mass. Now, for something like the mass of the sun, this is ridiculously long. The temperature is a millionth of a degree, and it's something like 10 to the 64 years. But if you take a black hole with a mass of 10 to the 15 grams, then the lifetime is precisely the age of the universe. So we were very interested in black holes of 10 to the 15 grams, because these are the ones which will be completing their evaporation and exploding today. Now, the fact is we haven't seen them, but we hope we would see these black holes exploding, because if we did, it will be evidence for primordial black holes and evidence for Hawking radiation, either of which we would have gotten the Nobel Prize. But unfortunately, we didn't find the evidence. So we make a distinction between the black holes which are less than about 10 to the 15 grams, which are no longer around, and the ones that are above 10 to the 15 grams, which haven't evaporated and could in principle make up the dark mass. So I personally love the idea that the dark matter could be primordial black holes, but that there could actually be a range of masses. So you could have one solar mass black holes which make up the dark matter. You could have somewhat bigger primordial black holes which could explain the gravitational wave detections of LIGO Virgo, and you could even have million solar mass black holes which are making the seeds for the black holes in galaxies. We know they're supermassive black holes in galaxies. You ask, how do they form? Well, there are many scenarios, but the most natural scenario is that the density fluctuations, which are generated by inflation and which make galaxies, on a smaller scale, are somewhat bigger and may make these primordial black holes. But there are actually quite a lot of scenarios. So that's summarized in a few minutes what is a sort of a lifetime's work. So
yeah, I'd love to discuss it more with you, but we want to move on to these other topics. One thing about dark matter, I wondered, is, you know how in various traditions they speak of other dimensions or other realms, like, for instance, in the Vedic tradition, they have 14 lokas or realms, and we occupy only one of them. Do you think that there's any way that all this unseen matter in the universe could actually be those other realms, or is that just is it really impossible to say?
Well, it has been suggested. I mean, the point is, in these theories, there can be other dimensions. And for example, in one of these higher dimensional theories, our physical world is just one. It's called a brane, B-R-N-E,
like a membrane,
B-R-A-N-E.
right?
It's a brane in a higher dimensional bulk. It's called B-U-L-K. And so, in these models, you could assume that you have not only one brain. You could assume you have lots of brains. You could have. This is one of the multiverse scenarios where you have lots of brains in this extra dimension. And in this case, you can have a theory of the dark matter where it's called shadow matter, where in some sense the dark matter is associated with the other brains. Now, this isn't my own favoured scenario, but as I say, we don't know what the dark matter is, so all bets are still on in a certain sense. But later on, if we ever get to later on, I'm going to argue that these extra dimensions are very important for accommodating mental phenomena. In other words, I'm associating the higher dimensional space with mind rather than matter, whereas this other idea is saying that these other brains are in some sense just different levels of matter. But I just wanted to stress that, it is a possibility that these higher dimensions have got some connection with the dark matter. It's just not my favourite picture, because I prefer to use these higher dimensions for other reasons.
Okay, good. Now, our other headings that we wanted to talk about, and we've already covered some bits from these other headings, but let me just read them to you quickly, and you can decide where we want to go next. The second one was time and consciousness. Another was science, spirituality, and psychical research. Another was quantum theory, and another was post-materialist science and hyperspatial models. So of all that, where should we go next?
Well, I think because of its generality, should we next talk about science, spirituality, and psychical research?
Okay, good.
So let me explain where I'm coming from, because, I mentioned when I talked about my initial interest in these subjects arising from reading these three books about, Einstein's relativity, Dunn's experiment with time, and Lampe and the third eye. Those are my three interests: science, psychical research, and spirituality. And I very much saw psychical research as bridging those two. I've always been passionately interested in connecting those three domains. Because I am a professional scientist, I'm very impressed with how successful science, and in particular physics, has been in explaining the material domain. It's been natural to me to try and expand science to accommodate not only matter, but also mental phenomena and spiritual phenomena. Now, there are two separate steps there, and I guess it's important to differentiate them. The idea that you can expand science to accommodate mind is relatively uncontroversial now. I mean, obviously the whole of psychology is based on the assumption that there is a science of mind. There is also developments in cognitive science, which connects that. But in particular, what interests me originally was my interest in psychical research. Because psychical research, although very controversial among scientists, it suggests that that consciousness can directly interact with the physical world. Well, obviously consciousness, it does interact with the brain. We don't understand that either. But the idea is that there can be an interaction with the physical world which doesn't go through the brain. So, for example, if I here is a little bear, and if I'm able to focus on this bear and make it levitate without holding it, there is an interaction with the physical world, which is not explained by current physics. And yet, if there is an interaction with the physical world, and if you believe that physics can explain all of the physical domain, there has to be an expansion of physics. So to me, that is one reason why I think one needs to expand science to accommodate consciousness. Because psychical research suggests there is interaction with the physical world. That's why it provides a link, if you like. Psychical research provides a link between matter and mind. But even if you don't believe in psychic phenomena, I think there are other reasons to think that consciousness should be part of physics. I've already argued that, that in some sense consciousness is fundamental, and I've argued against the idea that ordinary physics is close to a theory of everything, because although it's been tremendously successful, current physics is describing a universe without any reference to mind. It's basically a mindless universe. Okay, it's a study of mindlessness as opposed to mindfulness, which meditators obviously are more interested in. And so a description, half my experiences in the world are not in the material domain. They're the experiences in my memories, my dreams, my psychedelic experiences, my out-of-body experiences. I mean, I don't have many mystical experiences that people do. And I want a description of a real theory of everything. I want a description of mind, and if possible, I want to expand physics to accommodate those, at least some aspects of mental experience. And so I feel very strongly that should be done and can be done. And of course, I'm in good company. There are many other great physicists who believe that eventually physics must expand to accommodate consciousness. They're a minority, but I mean, someone of the prestige of someone like Roger Penrose, for example, clearly believes that your final theory of physics must somehow make reference to consciousness. On the other hand, I have to say that people like Roger Penrose aren't interested in mystical experiences, so and probably doesn't believe in psychic phenomena. But as a first step, at least, you have to expand science to accommodate mental experience. And not only that, I mean, physics itself is really only providing a mental model. Classical, the normal materialistic physics of Newtonian theory, and indeed Einstein's theory, that died with quantum theory. We know the normal materialistic view died, early in the 20th century. So in any case, we have to have an expanded physics because of quantum theory, and even more so when we get onto things like quantum gravity. So the question is can that accommodate consciousness? And I personally think it can. I personally think that I don't think that ordinary quantum theory can explain it. I think there is a link between quantum theory and consciousness in the sense that for the first time, quantum theory suggests that the observer may play a role in physics. We may get onto this topic in greater detail later, because, of the idea that the observer consciousness may collapse the wave function. So there is at least a hint from quantum theory that consciousness, the observer, mind, does play a role in physics. And so it's very important. And of course, that's a link which is very much stressed. Personally, I don't think quantum theory is going to provide a full theory of mind. I mean, I think it may be relevant to mind, but I don't think you're going to explain my out-of-body experience, my near-death experience, or even my existence and my perceptual experiences in terms of quantum theory. It's clear that you need a deeper theory which is going to underlie both quantum theory and mentality. Because the point is, we don't understand quantum theory anyway. I mean, we know quantum theory works, the equations work, but we know that there's no unique interpretation. And of course, people have been arguing about this for 100 years. There are many interpretations of quantum theory. It's a mystery. And to me, to say quantum theory explains mentality, it's just replacing one mystery with another mystery. What we need is a deeper theory which underlies quantum theory and mentality. But the whole point is that's going to happen anyway, because we know quantum theory and relativity theory are incompatible. They work very well with amazing precision in their own domains. Relativity theory works in the macroscopic domain. Quantum theory works in the microscopic domain with amazing precision, 12 places of decimals or whatever. But we know these theories are fundamentally incompatible. That's been known for 100 years. And so the aim in physics is to find a unified theory which marries up quantum theory and relativity theory. And my point is that in that final unified theory that you're going to find consciousness. Not in relativity theory alone, not in quantum theory alone. It will be in the final theory. So, for example, when you hear physicists like Sean Carroll saying the existence of psi is incompatible with physics, to me that makes no sense. It's maybe incompatible with known physics, but we know that known physics isn't the final story. We cannot possibly say what will be compatible with the final theory of physics. So all I would say is that if you want an extension of physics to accommodate mind and consciousness, it better be at the level of that final theory, which marries up quantum theory and relativity theory, not at the theory of quantum theory alone. So I know a lot of people are very enthusiastic about quantum theory because it's got many weird phenomena like entanglement and non-locality, and that's good, because it all hints that mind is important, but it's not, in my view, the final solution. The final solution has got to be there with your final theory of physics. Now, all of this is to do with expanding science to accommodate the domain of mind. Now, I want to go even further. I want to expand science to accommodate the domain of spirit. Now, that, of course, is much more controversial. But the trouble is, it seems to me that there is no clear-cut distinction between a psychic experience and a mystical experience. In other words, once you accept that mind is fundamental, it's the first step on a slippery slope to spirit. Because, I mean, just to take a simple example, I mean, obviously I'm interested in spiritual experience. I told you how I got interested in religion at a young age, but also I've meditated and I'm not very mystical, but I've had some, very modest spiritual experiences which convinced me that there is a deeper reality out there. And so I want to accommodate, I want to expand science and physics even to accommodate these as well. And my argument is that I can't see how I can make it, that the phenomena which link mind and spirit are sometimes called transpersonal, the domain of transpersonal psychology. And if you look at, and transpersonal experiences include in some sense psychic experiences, but they also include things like out-of-body experiences and near-death experiences and psychedelic experiences and mystical experiences. And so the point is, where do you draw the line between a psychical and a mystical experience? I don't think there is a clear-cut distinction. You see, if you could have an out-of-body, let's say somebody levitates, okay? Teresa of Aquila levitates. And you can say that's a psychic experience because levitation is what we call a psychical experience. Okay, you have a physical body raises from the ground. And you could say, that's psi, okay? But it's not, because we know from her perspective it was a mystical experience. She is having a mystical experience when she levitates. So there is a link between that mystical experience and the levitation. If I have a near-death experience, if I have an out-of-body experience, it's not only a paranormal experience in the sense that I seem to be wandering around the physical world, it's also a very spiritual experience. It can lead into a very spiritual experience. You may encounter other intelligences, you may enter other domains of reality. So from my perspective, there is no clear-cut distinction between, if you like, psychic and mystical. There is no clear-cut distinction, if you like, between mind and spirit. And indeed, it's because I have my own view as to how I can expand physics to accommodate spiritual phenomena that I take this view seriously. But even without reference to a particular theory, it's very hard to see how you can have an expansion of science to accommodate mind without also accommodating spirit.
Yeah. Well, when the Lewis and Clark expedition explored the Western United States, they ended up drawing a very, very crude map of the topography of the country. And of course, these days we have it mapped down, with satellites and everything else just to the cubic foot. I mean, everything, we know precisely where everything is. So I think that in a sense, various traditions have given us maps of the territory of consciousness and of mind. And, a lot of them are couched in ancient terminology, and they all have they've gone through various translations, and they all have varying degrees of clarity and accuracy, perhaps, or correspondence to what actually exists. But I do think that there are subtler levels of mind, a great range of them, and the various experiences you alluded to might fall at various points on those within that spectrum. And then there's a level which transcends mind altogether, which we could say is some kind of ground state or field of consciousness, which is like the ocean without ripples. The Yoga Sutras talks about that yoga or union with that field is the cessation of the fluctuations of mind. And the people have been exploring all this whole territory throughout history, and people are exploring it currently. And, but there's so much work to be done to just completely map it out and put it in modern terminology. And
Absolutely.
One more thing I want to say before I bounce it back to you is that, like, if you were to levitate that ceramic bear that's on your desk, or if you were to levitate yourself, as reportedly, many people throughout history have done, and it's, we can brush those off as myth, but if someone were actually to perform it or to demonstrate it, it would be a huge anomaly. And, you can call it a psychic or mystical experience subjectively for the person doing it, but they are in great violation of the laws of nature as physics currently understands them. And so how in the heck would physicists come to terms with that, presuming it could be verified and they could observe it and everything else? Seems to me they would have to completely rewrite the paradigm of the relationship between consciousness and the laws of the physical universe.
Well, absolutely. So, this comes down to what your particular theory is, what your extension of physics is, and whether that can explain something such as levitation. I could address that question within my own particular approach, and maybe we'll come to that later. But of course, it all comes down to whether you believe the phenomena. Now, many physicists, of course, would not believe in levitation, and therefore they say we don't need to expand physics to explain it, because it can't possibly be a real phenomena, because it's Newton's law says that you can't have levitation, you have to feel gravity. But
they say that even now with the stuff Dean Radin is coming up with. They say, well, I'm not going to look at your research because it can't be true.
Exactly.
But if you had enough people doing it that they couldn't avoid it, then they'd have to.
It's an absurdly narrow view. And people take this view. They say, well, I don't need to look at the evidence because it can't possibly happen according to my theory. But we don't have the final theory. It's a completely, to me, it goes against the very concept of science, which is that you should be open to all phenomena. But if you take something like levitation, now I have to say, for example, that I was somewhat skeptical of levitation. On the other hand, I was interested in our out-of-body experiences because I had out-of-body experiences. So in that sense, I would experience a levitation in the sense that you rise from your physical body. But of course, it's not a levitation of the physical body. It's a levitation, if you like, of a mental body. So I was always open to that, but I was a little bit skeptical of physical levitation because I've never physically levitated, and I've never levitated even the bear. However, I have to say I've somewhat changed my mind, because you read some of the literature. For example, you read about Joseph of Cupertino,
right?
And he was witnessed by hundreds of people levitating. I believe it's even true that at one stage there were so many monks levitating that the Pope declared it would only be a miracle if they weighed more than 10 stone or something ridiculous. But the point is that you have to be open for, when you're talking about psychic phenomena, there's a whole range of these phenomena, and I've always taken the view, don't accept or reject anything, So I don't reject the possibility of levitation, even though I've never seen it. The only view I would take is that when you read the literature of something like Joseph of Cupertino, which is well recorded, it's almost as though he would be in a mystical trance, a mystical state when he was levitating, and it was like he was in a bubble, like he was like in a dream bubble in which the normal laws of physics didn't apply.
You mean it would appear that way to observers, that he was in some kind of bubble?
No, it's not like you'd see the bubble, but for example, his clothes, he would go through fire and his clothes wouldn't burn. If he was holding somebody, I think it was a case where he was holding a child or something, and the child also was levitating. So it's though there's a region which is in some sense doesn't abide by the normal laws of physics. So it's what I always call fancifully a dream bubble, because I'm interested in relating dream space to physical space. And so, and as if we come on to it later, the idea is that this dream bubble is associated with the higher dimensional space. So it's as though you've got an intrusion from a higher dimension in which the normal laws of physics don't apply. There may still be laws, as in a dream, but not the normal laws of physics. So that's a sort of glimmer of how you might begin to explain something like this. But of course, there's no doubt that if levitation does occur, it's a tremendously rare phenomenon. I mean, at least the people, it's never been observed in a laboratory, for example. And I'm not saying whether I believe or disbelieve in levitation, because, you know, all of these phenomena, you have a sort of a boggle threshold as to what you're prepared to believe. And I really don't know for certain whether I believe in levitation, but I don't completely reject it. On the other hand, I do believe quite strongly, at least attribute high probability to certain psychic phenomena like telepathy and precognition, and micro-PK, the sort of stuff that Dean Radin does, for example.
Yeah.
So I'm relatively convinced that those phenomena exist, but in some sense, the more macroscopic the phenomena, the more you have to question it, obviously.
I think also the higher level of spiritual mastery you have to perform it. You know,
well, that is also true. And what is interesting, of course, one reason why one wants to draw this link between psi and mysticism is because traditionally there always has been a link. I mean, you know, within the mystical tradition, the idea that as you evolve, you develop so-called siddhis or psychic powers is really standard, you know. And so it's accepted within a mystical tradition or a spirit tradition that you do develop psychic powers. It's just that it's not encouraged, you know, because the psychic powers are a
distraction,
a flower on the wayside. So, although I like to think there is this link between psi and mysticism, and there is a sort of bridge between them, it's not a bridge that either side are very keen on. Psychical researchers don't like to refer to mysticism because they want to give the impression they're scientists and not mystics, and they know if they start talking about mysticism, they're going to get rejected by their mainstream science colleagues. On the other hand, mystics aren't too keen on psychical phenomena because it seems to be, it's too reductionist. It tends to be reducing everything to physics. So neither side is so keen on making this bridge, but I just think you have to build that bridge. This is the bridge, if you like, between mind and spirit.
So let's say that, for instance, let's just say that levitation were actually more common right now, to the point where they didn't bother to report it on the evening news anymore, you know, because it just kept happening, and anybody who really wanted to witness it could do so. And so what you're saying, your best guess at a explanation for it is that there might be some higher dimensional principles of physics which are somehow descending to apply to the particular, you know, the person levitating.
Yes, but I mean that I haven't yet gone. I can talk later about my own particular approach at this time, which is what I call the hyperspatial approach.
You can do it now if you want. We can get into it if you want.
Yes, okay.
Well, unless that takes us away from something we wanted to finish here.
Well, before getting into the technical, but yes, absolutely. But the key point I'm making is that if levitation were true, and again, I'm not saying it is, but if it were true, you would need a theory of physics to accommodate it. You'd need an expansion of physics to accommodate it. Now, regardless of whether my particular model is the right one, I would stick by that statement. Now, of course, you could simply say I don't believe the phenomena, but that is, in general, not the way to go, because if you did that...
But if it became that common, you couldn't say it anymore. So,
well, you'd never expand science beyond matter. It would always be restricted to the material. And the fact of the matter is, some of the phenomena which arise in physics are just as weird as some of the phenomena that arise in psychical experiences, in a sense. But you made another point, which is really that, in some sense, that trying to make a link between science and spirituality is nothing new. I mean, of course, the ancient religions have been doing that for thousands of years. More recently, the occult traditions, you know, have had quite sophisticated, you know, be it theosophy or Kabbalah or whatever, they're quite sophisticated models which accept there are different levels of reality that go beyond the normal material reality. And so I think that's the key message I'm trying to get across at this point, that the assumption that the only level of reality is material reality, which is actually what many scientists assume, I don't think is justified. I mean, it's very simplistic. Ordinary materialistic physics died 100 years ago anyway with quantum theory. Physics anyway introduces all these weird ideas like fields and quantum wave functions and extra dimensions, where we have to go beyond materialism anyway. And so I think you have to be open to that to that expansion. And traditionally you always see science and religion as being in opposition. Ever since the days of Galileo, you have this vision that science is progressing despite the efforts of the church to hold back, because they want to believe in that God is behind everything, and there is therefore this antipathy between science and religion, and historically that's true. But I don't think there does need to be an antipathy between science and religion. I think they both represent valid levels of reality, and which only appear to be in conflict. I think you've got matter, mind, and spirit, and they form a coherent whole.
Yeah.
And you have to try and unify them. They're not in conflict. And in some sense, when you talk about the conflict between matter and spirit, or science and spirituality, science and religion, it's helpful to think of this third world, the world of mind, because that's what links them. So it's not just reconciling science and spirituality, it's reconciling science and mind and spirituality. The three things go together.
Swivel your chair just slightly, because the sun's peeking over your left shoulder, and if you just swivel slightly, you'll block it. A little bit more.
You mean the sun and the...
Yeah, the sun coming through the skylight is just...
That's the other
there.
sky. I can...
Okay, good. Perfect. A little bit back the other way. Perfect. Okay.
I don't want to... it looks like my halo if I'm like this, which may impress people. I don't know.
Yeah. It'll increase the view count here. When we talk about science versus religion, I think that the two can be reconciled. And I think that some so-called religions are really very scientific. They are empirical. They don't place emphasis on belief. If certain things are taught that people haven't experienced yet, the teacher is generally not saying, believe in these things or you're doomed. He's saying, okay, here's a vision of possibilities. Now do your research, do your practice and see if you can confirm this experientially for yourself. So the Eastern religions tend to be that way a little bit more, at least in their pure forms, whereas the Western, kind of got corrupted, in my opinion, and became all about believing things and, that you can't ever necessarily experience until perhaps after you die.
Well, as you know, I mean, I have a bit of a Buddhist background. I'm a Christian, but I've also been very interested in Buddhism and the Eastern religions in general. And I think that science and religion help each other.
Yeah.
And they do it in various ways. For example, psychical research, for example, helps religion, I would say, by providing evidence for certain spiritual beliefs. For example, I think one of the evidence you get from psychical research is that our minds are connected, evidence that there's a level of reality that goes beyond the physical, beyond the material, evidence even perhaps for survival of consciousness after death. I mean, obviously that's controversial, but evidence for reincarnation, things like this. The whole point about psychical research is that it does purport to be a science. It's using the methods of science to study phenomena which cannot currently be explained. So in that sense, psychical research as a science is providing support for religious beliefs. I'm not saying all religious beliefs, but some aspects of religious beliefs. On the other hand, I would say that religious beliefs or religious philosophy can help science. Now, this is more controversial, but for example, I've been fascinated in some of the insights of the Buddha into the nature of the physical world through what he would call clairvoyance. Because the Buddha would claim that he could get clairvoyant insights into the nature of the physical world, that he could he would get information about the nature of interstellar space, galaxies, the cosmos. He would talk about visions of the cycles of the cosmos, the universe expanding and recollapsing and things like this. And this is actually quite very reminiscent of some of the ideas of in modern cosmology even. Now, of course, you have to be careful because there's a lot of scope for interpreting the ancient texts with the wisdom of hindsight to make it look like modern cosmology. But I have to confess, I don't see in principle, if you believe in such a thing as clairvoyance, in other words, that the mind can get information about the physical world directly, I don't see in principle why an evolved spiritual person shouldn't get information about the physical universe. And so, you know, you can even, Buddha in principle, if you read the sutras, some of the Buddhist texts, which are coming directly from his quotations, in principle, he can predict the time scale of the cosmic cycles, okay? And you can work it out, and it turns out to be something like 40 billion years or something. Well, of course, any modern cosmologist will be very skeptical. They're going to say, well, how could someone in 500 BC have all this information, which we're only today discovering through the Hubble telescope and the James Webb telescope? And of course, it just sounds a bit crazy. Nevertheless, that is the claim. So I don't, in principle, see why, if you believe in clairvoyance, why a spiritual evolved person shouldn't get clairvoyant knowledge about the nature of physical reality. And you get the same claims in theosophy, for example. So that's an example of how spirituality, if you like, can help science, as well as how science can help spirituality. Despite the fact that, by and large, most scientists are completely skeptical of anything coming from spirituality, and vice versa.
Yeah, but most scientists are not purely scientific. They're biased. You know, one way I look at it is that the human nervous system is an instrument which, in a sense, is far more sophisticated than the Large Hadron Collider or something, and you know, and it has capabilities which no man-made instrument has, if we just know how to use it to its full capabilities, its full potential. And in that sense, you know, we could have modern day Buddhas who would be able to do research in consciousness that could possibly reveal things about the universe that scientific instrumentation cannot yet reveal, or could also reveal in its own way, and the two could, you know, corroborate.
Absolutely.
Yeah. And on the flip side, go ahead.
I mean, I was going to say, you know, I haven't really spoken about it explicitly yet, but my own hyperspatial model says there are these extra dimensions. Well, physicists are looking for extra dimensions as well. They're looking for them with the Large Hadron Collider, for example. They haven't yet found them. But I would say that there's more evidence for extra dimensions that come from spiritual experience, if you like, than there is through physical experiments. That doesn't mean to say there will never be evidence from physical experiments, but nevertheless, the idea that the human psyche is another very sensitive instrument for probing reality is crucial. I mean, and it may not cost $1 billion to build a human brain, but that doesn't mean the brain can't be sensitive to these other levels of reality, and I think that's really important. And you know, most physicists aren't going to accept that because they don't believe the mind can possibly be sensitive to these higher realms. But I'm afraid that's just where our views differ.
Yeah, like we said, you know, a series of funerals. And also, I mean, science might be able to detect these other dimensions in some kind of in some sort of way, but they wouldn't be able to provide the experience of them. And yet what we're suggesting here is that human beings can actually directly experience this stuff in ways that, you know, even if an instrument could somehow tune into it and you're just looking at, you know, indicators on the instrument that something is happening. It's like you know, you can detect through brainwaves whether a person is dreaming, and we know they're dreaming, but that's not like experiencing the dream. It's just squiggles on a graph. So, you know, science has its realm, and
nevertheless, I hope that science will detect these extra dimensions. I mean, they are looking for them in accelerators. They haven't found them yet, but that doesn't mean they won't find them eventually. It's all to do with the size of the extra dimensions. And to me, what is fascinating is when physics finds these extra dimensions, that is what is going to provide the potential link between physics and mental phenomena. And so, because in my theory, which I still haven't described in detail, the higher dimensions of modern physics link to, they provide a space for, if you like, mental experience. And that's a weird thought, because the point is that if you start finding higher dimensions in an accelerator, to say that that's something to do with mind is really, throwing a cat among the pigeons. I mean, you can see that won't go down well. But nevertheless, that would seem to be the implication, that you really are, in some sense, beginning to probe mind as well as matter. Because when you get to the limits of our knowledge of matter, you see, when I say that the final theory of physics is going to accommodate consciousness, that is saying that at some point, probing matter in extreme conditions is going to become a probe of consciousness. But in that case, consciousness itself can probe it. So there is this link. And although I know it won't go down well with most physicists, the idea that extra dimensions provide the arena for mental experience, that just happens to be the paradigm I'm fascinated with.
There's an old Bengali saying which goes, if no one comes on your call, then go ahead alone. So I think you're going to have to stop worrying about what most physicists think. I mean, you're retired, aren't you? Or you're close to it.
I'm now emeritus, and at least I understand there are at least a few other people on this call, so at least some people are listening.
Yeah. And just maybe you should explain your theory in full now, but let me just throw in one quick thing before we do that to wrap up our previous part of discussion. And that is that I also think science can help spirituality a lot, because spirituality, at least contemporary spirituality, is very prone to imagination and all kinds of woo-woo, People can just go off on all kinds of crazy tangents and think that they're making spiritual progress, whereas in fact they might just be going into some fantasy land. So I think that, without getting all skeptical and too hardcore about it, there's some elements of the scientific method which can be applied to spirituality to make it more empirical, more practical, more insistent upon, the reality of what you're experiencing to save you from going off into fantasies.
Yes, but you have to be careful here, because what is relative is crazy. What is crazy is relative to your perspective, because I referred earlier to the Boggle threshold. Now, I mean, I get sent papers a lot by people from a spiritual background, and I might say to myself, oh, that's crazy, they don't understand the physics properly, that's crazy. But I know that other people, some of my physics colleagues, they will look at what I'm writing and they will say that's crazy.
Yeah.
So what is crazy? It all depends on your perspective. You have to be very careful. Because I'm a cosmologist, because within my cosmological work I'm reasonably respectable, I think that sort of, in some sense, adds credibility to what I'm saying about mind. But on the other hand, a lot of my cosmological colleagues will merely infer that I'm crazy after all, and
going
maybe
off the deep end, right?
Cosmology ideas are crazy, or some of them will just say, "Oh, he's retired," and physicists often go gaga after they're retired. And, well, maybe all I can say is that I've had these crazy thoughts ever since I was young, ever since I was 15. So if they are crazy, it's not a result of age.
Well, just maybe another way of putting it is that just as science wants to understand what's what, what's actually happening, what is this world, how does it work? Spirituality in its purest form wants the same thing. The practitioner wants to become a knower of reality, to become aligned with the truth. If there's some deep ultimate reality to the universe, and if we ultimately are that, they want to realize that. So but there can be many pitfalls on that path where people go off on tangents and become less grounded or less aligned with what's real instead of more.
Yes,
anyway, that's what I was getting at.
But the other important point is, you were referring to the Eastern religious traditions. The point about that, especially within Buddhism, which I'm most familiar with, it was an attempt to understand these other domains of reality, other experiences of consciousness, from a scientific perspective. In other words, it wasn't the idea that, there's this idea that science is rational and is experiments, and mysticism is completely irrational. And that's the whole point of these Eastern traditions, is that you're actually applying rationality to these phenomena, and they're classifying them in a very sophisticated, they're classifying the experiences of consciousness in a very sophisticated way. I would say more sophisticated than in Western theology, for example. And indeed, you see references to inner science. It's the science of inner space as opposed to outer space. And that's important. That's why I'm saying you should try and make it part of science. So although you have to be careful in discriminating between what is crazy and what is sensible in this domain, because some people will say it's all crazy, I do think a useful criteria is whether in some sense it's part of science, whether you're using the procedures and the rational tools associated with normal science.
Good. I think we're in agreement. It's all right. We've covered that point. So what else do we want to cover before we have to finish? Did you want to more thoroughly explain your theory of? Yeah, go ahead.
Give me a time scale though. So how long can we interview go on for?
There's no hard and fast limit. We don't want to go on for 4 hours, but if you want to go on for a bit more, go at it.
It's just a question of how succinct time, but obviously I'm thinking about the audience. But anyway,
well, we'll lose some, but some will hang in there.
By giving my own particular view, I've explained that that I think science has to be extended beyond the material domain. This is part of what is sometimes called post-materialist science. There is a whole movement now. There's an Academy of Post-Materialist Science, which basically are wanting to expand science beyond the material domain into the domain of mind and spirit. And for example, that is something called the Galileo Commission. I'm associated with what's called the Scientific and Medical Network.
Yeah.
It's currently its president, which is basically interested in the links between science and spirituality and the role of consciousness.
Yeah. I'm on their mailing list, by the way, and people listening to this could get on their mailing list because they have lots of interesting conferences.
Absolutely.
You
it's
can watch.
Very active. I mean, maybe you could give the website, because they're hugely active, especially during this pandemic period.
Right.
Zoom meetings and discussion groups. I mean, obviously, I would like to propagate
I'll provide links on your BAPGAP
as much
page
as I can. But the reason I'm mentioning the Scientific and Medical Network now is, in particular, they are pushing this post-materialist science idea with what's called the Galileo Commission project. But anyway, so I'm just putting my efforts in a broader context. But now I want to talk about how I think we can go about this. So this is my personal view. As a physicist, I've always been very impressed with the fact that physics invokes higher dimensions. And this, of course, we know Newton's theory was three-dimensional, but we know Einstein's theory introduced the fourth dimension, time. So reality became four-dimensional rather than three-dimensional. In the 1920s, two physicists called Kaluza and Klein, they tried to give a geometrical interpretation of the electromagnetic interaction in terms of a fifth dimension. Einstein had given a geometrical interpretation of gravity in terms of curved space-time. They said, well, we can also explain electromagnetic interactions if we have a fifth dimension. But it has to be wrapped up very small on what's called the Planck scale, which is tiny, 10 to the minus 33 centimeters. Now, even Einstein quite liked this idea, but people basically forgot about this because they got distracted by quantum theory. But then in the mid-1980s, string theory came along, superstring theory came along, and said we can now have a unified description of all the forces of nature if we introduce more extra dimensions. And in fact, string theory originally had 6 extra dimensions. So you had 3 space, 1 time, and you had 6 extra dimensions which were wrapped up, but on a very small scale. So this was 10-dimensional. And the hope was that maybe this would be the final theory of physics. There were quite a number of different theories, versions of string theory, though. And then in mid-1990s, it was realized all of these theories could be merged as part of another theory called M theory. And an M theory has an extra dimension, so it has 11 dimensions. But we didn't get into the technicality. The point is, these theories, which very respectable physicists are working on, imply they are extra dimensions. Now, there's still no extra evidence for these extra dimensions, so some people argue it's maths rather than physics, so you get a similar debate about whether M theory is physics as you do about whether the multiverse is physics. But nevertheless, the idea of extra dimensions is very popular in physics. Not everyone believes it, but at least in certain quarters it's very popular. And indeed, a particular model I like is that the model which I referred to before, in which our physical world is just a brain, a four-dimensional brain, B-R-A-N-E, in a higher five-dimensional bulk. The idea is one of these extra dimensions, instead of being wrapped up on the Planck scale, is extended. But then you see, if we are just a slice, if the physical world is just a slice of the higher dimensional world, you've got to say, well, what else is there in this higher dimensional space? So let me just park that thought. But then, when we come to talk about mental phenomena, what fascinated me is the fact that nearly all mental phenomena involve some form of space. And, I mean, even ordinary perceptual space, phenomenal space, we know phenomenal space is not the same as physical space. I mean, this is what Donald Hoffman, emphasized. The phenomenal space is just the representation of physical space. So there's even a basic philosophical question there, the relationship between what's called phenomenal space or perceptual space and physical space. But I'm talking about things like memory space. I'm talking about dream space. When I have a dream, it takes place in a space, just like physical space. In fact, I sometimes can't even tell whether I'm awake or dreaming. I mean, I'm hoping I'm awake now, else I've wasted it. But nevertheless, I've done it. I have lucid dreams, and I'm sure other people listening do. I can't sometimes tell the difference. It's like physical space. I mean, obviously there are anomalies in the laws, but it's got spatial features. If you have an out-of-body experience, I mean, I've had out-of-body experiences. I realize most people think they're just hallucinations, but the point about out-of-body experiences, you're in a space. And it looks rather like physical space, but it's not identical to physical space because there are subtle differences. And
although a lot of times people have them and they actually see things which are later verified, Yeah.
So you leave your physical body and you go somewhere else and you see an event. That's what we call clairvoyance, or maybe somebody even sees you. Sometimes people see the astral body. So, but then the question is, well, is it clairvoyance or is something really leaving the body? But the point is, experientially, it is a space. And near-death experiences, now there's a lot of literature on near-death experiences, people, cardiac arrest or something, but they're floating around, they go through a tunnel, then they enter another realm and they meet dead, deceased loved ones and things. It's in a space. And even most mystical experiences, many mystical experiences, the so-called extroverted ones, involve a space. Psychedelic experiences involve a space, which is sometimes even explicitly described as higher dimensional. I mean, talk about ghosts, for example. Most people assume that apparitions are just hallucinations. It's not as simple as that, because you have collective apparitions where more than one person may see the apparition at the same time. So it's in some collective sort of space. So I would say the key thing of all these phenomena, mental phenomena, is that they involve a space. So the question is, what is the relationship between that space and physical space? Now, it can't be the same as physical space, because I don't believe a ghost is existing in physical space. I don't believe when I have a dream I'm actually in physical space. But I do believe I'm in some space. And I'm led to the hypothesis that you need to be in a higher dimensional space. And in some sense, you have a hierarchy of experiences in psychical and, well, normal psychical and mystical experiences. And this hierarchy of spaces in some sense involve a hierarchy of dimensions. And I have in my model, I invoke what's called a universal structure, which is basically a higher dimensional reality structure of which the physical space is just a slice, and all mental experiences are part of this structure. So if you like, it's an expanded reality. So now you've got that thought. Now go back to the original thought about physics having expanded space as well. So to me, it seems fairly natural to marry up these two ideas and say that maybe the higher dimensions of physics can accommodate the mental space which I'm talking about. Now, this is not an idea that most M theorists would like. They'll probably be rather horrified, at the idea, because they're trying to convince people this is respectable physics, and they're not going to like the idea that the idea is being tainted with all these mystical connotations. But that's the way that's the way my model goes. That you're making a link between higher dimensions, and that's why it's called hyperspatial, because hyperspatial means beyond the normal 3 dimensions. And so that is my particular approach, and really what this higher dimensional space corresponds to, it corresponds, if you like, to a sort of universal mind. Because it's based on mental experience. So it is mind, but it's mind with a big M, to go back to the earlier part of our conversation. And what it's saying is that our minds with a little m are not just separate bubbles inside our heads. It's saying our minds with a little m are all part of this big mind with a big M. And that's why in this approach you can have things like telepathy and clairvoyance, because all our minds are connected, and our two minds are connected as part of this space, but also our minds the physical world is part of the space, so this mind can also experience the physical world directly. So that's my model, if you like, not only for mind, but for transpersonal experiences as well. But then you come to the question of what are the extra dimensions? And now you come on to the question of time and consciousness. Because you remember I've been talking about consciousness at various points in this discussion. The distinction between consciousness with a big C and a little c. I've never really tried to define what consciousness is, because of course that's rather difficult. But I'm now, when I'm talking about mind, I'm really talking about contents of consciousness, okay? These different experiences, dreams, out-of-body experiences, they're the contents of consciousness. But now let's come on to the question of consciousness itself. What is consciousness itself? Well, one of the key things about consciousness is that it involves the passage of time, okay? We experience the flow of time from past to present to future. Now, that cannot be explained by relativity theory. Even though relativity theory is that, such a success in merging space and time, in 4-dimensional space-time, it doesn't explain the passage of time. Because in relativity theory, you have the block universe, which says that the past, the present, and the future coexist. You might naively think, if you think of your brain as like a line, the world line of your brain is like a line in space-time. And you might think that the passage of consciousness was rather like a little bead going up this wire. Okay, so past becomes present, becomes future. Okay, so, future becomes present, becomes past. So, but the trouble is, the passage of time cannot be explained by relativity theory. There is no passage of time. The situation in quantum theory is a little bit unclear, because time, it may exist in a certain sense, but time, even the passage of time in quantum theory isn't well defined. So it seems to me obvious that you've got to go beyond relativity theory in order to explain consciousness. You cannot explain the passage of time, which is to me part of consciousness, in terms of relativity theory. You've already got to go beyond relativity theory. And I argue that even the passage of time, even before you get into anything controversial like anomalous phenomena, has to involve, I would argue, another dimension of time. Because relativity is talking about physical time. I'm arguing that you need another dimension of time to describe mental phenomena. And so I argue that you need a 5-dimensional model even to explain ordinary physical perception. Because the ordinary consciousness in physical perception requires a passage of time. So that's the first remark. Of course, philosophers have been arguing about this for a century. Centuries, how you describe the passage of time, and everyone disagrees. But most people seem to agree that the passage of time is not part of standard physics. You've got to go beyond standard physics. But the other component that fascinates me, and which seems to be very neglected by philosophers and physicists now, is the concept of the specious present. Now, the specious present is the minimum time scale of conscious experience. Now, for humans, that's something like a tenth of a second. It's the minimum time scale that you can be aware of because there's the Julian function, the brain process. So, for example, I give this. You imagine a light going around in a circle. You see it as motion. If the light goes around more than 10 times a second, you don't see it as a motion. It just becomes a continuous light. Okay, so space has become time, and that's because basically your temporal resolution is too low to see is too big to see the motion.
Yeah, that's how a movie works, really. I mean, so many frames per second, and it looks like a smooth thing, even though you're looking at static frames.
Right, exactly right. I mean, exactly the same thing happens with movies. I mean, there is whatever it is, it's a 30th of a second or something like that. You don't notice the individual frames because your speech is present, as you say, is too long. Now, there's also an upper limit to your time scale perception. If it's too long, if the light goes round too slowly, you don't see it moving either. It seems to be frozen. And that's the time scale for that's a little bit more ambiguous. It may be something to do with the short-term memory time scale or something. But the point is, we only experience consciousness through a window of a specious present, okay?
I just want to tell you, there was a great Star Trek episode where some beings came into the ship who were on a different time scale. And so from their perspective, the people on the Starship Enterprise looked like mannequins. They were just standing still. And from the perspective of the people on the Starship Enterprise, it was like mosquitoes were buzzing. They just heard this little high-pitched thing, because the others were moving so fast in comparison to their time frame.
I was a great fan of Star Trek, though oddly enough I don't remember that episode, but that's exactly the point, because the point I'm making is that why do we make the assumption that consciousness can only exist on the time scale we experience it? You know, we experience a flow of time over something like a tenth of a second to 10,000 seconds. Why do we assume there can't be some form of consciousness operating on a different time scale? Why, for example, I don't see why there couldn't be a form of consciousness operating on a nanosecond time scale, like a computer or something. I don't see why there couldn't be some form of galactic consciousness which has a species present in 1 million years.
Yeah.
It seems to be incredibly arrogant to assume that the only level of consciousness in the universe is human consciousness. And so it's rather like the electromagnetic spectrum. We know visible light is just a tiny band of frequencies among a huge range of wave bands going from, gamma radio waves to gamma rays. Likewise, I don't see why consciousness couldn't exist on completely different timescales. Now, if it did, we wouldn't be able to experience those other levels of consciousness. Well, you might have this, you described this Star Trek episode where you've got beings with two different species presence. I mean, we can change our species present to some extent. For example, I mean, if you're in a car accident, time slows down. I mean, I've been in a car accident, but many people have had that. Or you're falling off a mountain. But time seems to slow down. That's to say, your internal time relative to the outside time.
Yeah. Or you have a near-death experience and your life flashes before your eyes in great detail, even though it only takes a few seconds for it to do that. Well, that's another situation.
In a near-death experience, you can experience your whole life in one go. In other words, you don't experience it as a flow. Your whole life, 100 years, if you're lucky, you see in an instant. So I think there are experiences in which the species present changes, even for human beings. I think there are mystical experiences where the species present can change even more dramatically. I think there are mystical experiences. Sorry, I'm quoting the literature, not going from experience, but it is claimed there are mystical experiences where the species present can expand, to the whole history of the universe, or where it can contract to zero almost. So I think there's evidence that the species present can change drastically. And that consciousness can therefore exist on all these different levels. And so when you talk about consciousness, you're really talking about species present. And when you're talking about a hierarchy of consciousness, you're talking about a hierarchy of species presence. So I don't see why you can't have a human consciousness, a global terrestrial consciousness, a galactic consciousness, maybe even a cosmic consciousness. So when I talked earlier about the distinction between mind with a big M and mind with a little m, or consciousness with a big C and consciousness with a little c, what I'm really saying is in it's really a gradation, that you have a gradation of levels of consciousness corresponding to a gradation of levels of species present, which goes from our mind to the sort of great cosmic mind, and maybe even to below as well, maybe to smaller species present. Now, this is all speculation, because the whole point is that these different species presence, these consciousnesses with different species presence can't actually communicate with each other. You can't be aware of them. If I had a species present of more than 100 years, my lifetime wouldn't exist. You and me would not exist. Our identities would make no sense, because our whole lifetime is less than the species present of this high level of consciousness. So to me, the whole nature of consciousness, the whole nature of self-identity, all relates to the notion of species present. And just to put it in a nutshell, because all of this is very speculative, the species present to me, I associate with these extra dimensions in some way. In some ways, these extra dimensions are compactified, and I'm associating that with different levels of species present. So just as I invoked a higher dimension of time to explain the passage of time, I'm also invoking these compact extra dimensions and associating them with different levels of species present. All this is completely speculative. It may be crazy. I've not published it in physics journals, but I'm just trying to give an example of how you can try and link physics to these sorts of experiences.
I think there's really something to it. In fact, in the Vedic literature, they speak of various levels of higher beings, a whole hierarchy of them. And generally, the higher you go up the hierarchy, the longer they live. And some live as long as the entire universe. And even a human, it's said that when they go to a heavenly realm after death, they dwell there for a long period of time, even though it may not seem that long to them. And then maybe they come back and get reborn again or something. But anyway, the higher life on higher levels is said to be very long-lived.
Absolutely. I mean, and indeed, I'm partly motivated by some of the religious literature with ideas, especially within the Buddhist philosophy of things like that, because they do talk about beings, devas or whatever, with different time scales, time scales of existence. So I can't quote that in any scientific paper, but I'm partly motivated by that. But you see, what's the common thing to all of these approaches? It comes down to what is the nature of consciousness, and this is where you come against the rub, because the point is, most people assume that consciousness with a little c is generated by the brain. Okay, if these phenomena are correct, consciousness is not generated by the brain. What happens is that the brain is merely a filter of consciousness. So the idea is now you've got consciousness with a big C, if you like, this ocean. And wherever you have a physical system which is sufficiently complex, like the brain, that it can have memories and a model of the world and things like that, then it can act as a channel for this consciousness with a big C, and it can produce a localized consciousness with a little c. But of course, that is not the mainstream view of neuroscientists. In fact, almost all new scientists would reject it and say, no, the brain generates consciousness. But I would claim, and many other people have claimed, that actually it's very interesting to study the correlates between brain function and consciousness, but it's only evidence for correlation. It's not evidence for causality. That there is clearly, if you hit someone on the head, it affects their brain, their consciousness. No doubt about that. There's no doubt that so long as consciousness is filtered through the brain, when you do something to the brain, it affects the conscious experience.
Well, if you smash a radio with a hammer, the radio doesn't work so well.
Exactly. But if you smash a radio with a hammer, it doesn't mean the station stops broadcasting.
Right.
And this is basically saying that the brain is a bit like a TV set. That, that we experience the world through the TV set. But just because the television breaks down or gets a fuse doesn't mean that the transmission isn't there. Now, of course, this then leads to all sorts of suggestions that, well, maybe that if consciousness isn't generated by the brain, maybe consciousness can survive the death of the brain, and then you get into even more controversial areas. But I'm afraid those are the areas I'm also interested in.
Yeah, me too. And some would take it a step further to say that not only does the brain not create consciousness, but consciousness creates the brain. And by that, I mean the kind of stuff I was alluding to earlier, that, this ubiquitous field of consciousness or intelligence the whole physical universe emerges out of that and becomes increasingly complex, in order for consciousness to become a living reality, which is kind of a value-added situation that's more than just flat ocean of consciousness. It's consciousness embodied. So that I suppose from, we could say that's a lot of fun for consciousness or God. Leela is often the term used in Sanskrit. The universe is a play which is scripted or given manifestation by divine, or by, I'm trying to not use those kind of words, by the ocean of consciousness in order for it to entertain itself.
Yeah, I like that idea, because actually I was having this discussion the other day, that there is this idea that the whole world is a computer simulation. The whole universe is a computer simulation. It's very out of spec, probably even more crazy than some of the ideas I've been talking about. But the point is, there are very intelligent people talking about this. But then the question is, if we're all in a simulation, who is the programmer?
Right.
Is the programmer God? And then I said to this person, I said, well, if the programmer is God, normally when you program computers, you're trying to solve a problem. So I remember saying, if the programmer's God, what problem is God trying to solve? And then somebody else came in and they said, oh no, you got it all wrong. Nowadays, computer programs aren't written to solve problems. Most computer programs are now written for games.
Exactly. Very good.
So, in other words, the purpose of this computer simulation would not be to solve a problem, it would just be to entertain,
Yeah.
So, well, I'm not saying that God created us for his own entertainment, but those are the sort of amusing issues you have to confront, because it relates to what I said at the beginning. At the beginning, you see, if this universal structure, which is mind, if that's the more fundamental thing, if the material world is just a slice of this higher dimensional mind, it suggests that, well, before the Big Bang itself, and the Big Bang is a physical description of physics, the physical world, it says, well, this mind should have pre-existed the physical world. Mind with a capital M should have pre-existed the physical world. And so in a way this relates to the question we started off talking about, did some form of mind or some form of spirit create the universe?
Yeah.
And so it all links, but the point is, this form of mind with a capital M is, as I say, on a much longer time scale. This would be on a specious present, which contained the whole history of the universe. So the question is, what is the ultimate level of this hierarchy? Does it transcend space and time altogether? And I think that actually, again, going from the literature, the mystical literature, the final state, Parousia, is supposed to transcend space and time altogether. So I can well accept that the final state transcends any form of space and time, because the idea of a specious presence is that even when you talk about a hyperspatial approach, you're still assuming there are some dimensions. You're going beyond space and time, but you're still assuming there are dimensions. So the question is there a final description which goes beyond any space and any time altogether? And maybe that's the level at which you get the big M.
Yeah. Good. Well, maybe that will be a good stopping place. Maybe if we've ended up where we started in this interview, we're like that T.S. Eliot poem, that at the end of all our seeking, we shall arrive from whence we started and know the place for the first time.
Well, that's right. So there's a pleasing symmetry in that we've ended where we've begun. I can see we've nearly gone on for 3 hours, so I hope this isn't going to cause any problems. But
no, it's fine.
It's only with regard to our specious present and regard for a being with a different specious present. 3 hours could be nothing, or an eternity.
Yeah. Well, I could trivialize the whole thing and quote Kermit the Frog here, who said, "Time's fun when you're having flies."
Oh, I've never heard that before. Yes, that's lovely. Yeah.
Okay, great.
Slightly remark that infinity is a long time, especially when you get towards the end.
Yeah, who said that?
I don't know, but it's a famous statement. Yeah.
Yeah, Groucho Marx, what did he say? He said, time flies like an arrow, fruit flies like a banana.
And it's like, yes, well, now we're exchanging jokes. I love the Woody Allen jokes where he says he's not afraid of death as long as he's not there when it happens.
Yeah. Yeah. He also said, I don't want to attain immortality through my work. I want to attain it by not dying.
Yes, indeed. Well, maybe it's good to end on a joke, but I've really enjoyed this conversation. And
Me too, Bernard.
I suspect there are probably other questions which we haven't answered from the second part.
Oh, yeah, we could go on another 3 hours, I'm sure, but maybe we'll do that one of these days.
Well, I enjoyed it very much anyway, and
yeah, me too.
let me know when you've got the link.
Yes, I will, just in a few days. So yeah, thank you so very much, and thanks to those who've hung in there with us. Probably some of you have had to do this in separate sessions, but it's really been a lot of fun, and it's really been an enjoyable week for me, sort of delving into your work and then having this wonderful conversation.
Well, I'm very flattered that you spend so much time reading all my articles.
Oh, I love it.
I see we have actually more or less got through all of the topics which were on the list of questions too.
Okay, great. Well, a lot of it was way over my head, but it kind of expands my head to try to understand what you're saying.
Lots of it's way over my head too, but you have to. You can only try and make your head bigger.
Okay, good. All right. Thanks so much, and thanks to those who've been listening or watching. And next week, I'll be interviewing Jeffrey Mishlove, who has interviewed Bernard a number of times, and he does the Thinking Aloud, and then now it's called the New Thinking Aloud interview show, which has been going on for a long, long time. So I think that's going to be a fascinating conversation.
He is another wonderful interviewer, and he, of course, has also just won the Bigelow Prize for the on survival. So you have lots of interesting things to discuss. So you will be interviewing the interviewer.
I will. It'll be some kind of a feedback loop that'll be happening, like Jimi Hendrix or something in front of his amp. All right. Thanks, everybody. And thanks, Bernard.
Okay. Thanks very much, Rick. Bye-bye for now.
Bye for now.